Good morning, everyone. Welcome to this workshop. As it's just 9 o'clock Central European time, I'm going to wait a couple of minutes to allow people to join. I see that some people are recording the session. I would prefer if you didn't. We are going to share it on YouTube. So if you can stop your recording, that would be great. So again, if you can stop your note taker, that would be greatly appreciated. Thank you. Okay, so I'm going to get started. And if a few people join a bit later, then that's okay, because there will be a little bit of an introduction first. So my name is Nathalie Toublanc, and I will be your instructor for today. I've recognized some names, so welcome to this workshop, everyone. I hope that you are going to learn a lot about PKSIM and the OSP suite. And I just wanted to say that I've got some experience in the pharmaceutical industry. I worked 25 years in the pharmaceutical industry, 20 years in clinical pharmacology, 5 years in product development. Then I joined another company who was developing PBPK software and worked there for 3 years. And I joined ESQlabs 9 months ago. And I'm very happy to be here. So I'm going to share my screen. If you can let me know when you see my screen. Yes. One thing that I want to do first, I want this session to be interactive, and that's why I'm limiting the number of people who can attend. So I'm going to check from time to time that you are with me. There is limited way that we can interact. I mean, I can allow you to talk if you've got a question. Otherwise, you can put your question in the Q&A. And one of my colleagues is going to join at about 10 after the break. But there is another one of my colleagues who is here, and she's going to let me know if there are some questions. So one way also that you can interact with me is by raising your hand. So I'm going to ask you a question, and if you can raise your hand, because that's the only way that we can interact. So can you raise your hand if you've got some theoretical knowledge about PBPK? Okay. So it seems, I would say that and you can access the chat. I didn't know. I think it's a new feature for this one. So great. Thanks, Manish, for your answer. Okay, and some say advanced and basic. Okay, that's great. So I think we've got heterogeneous population because some people didn't raise their hand, which means that they don't have PBPK knowledge. We are going to cover really basic PBPK, but most of the workshop will be on hands-on for you to learn and to get your first step with PKC. Okay, Konstantinos. So if you can't hear me, Konstantinos, I think that it's a problem on your side, because I guess that other people can hear me. So maybe the best is for you to disconnect and reconnect, and hopefully it's going to work then. Okay, and okay, so can you raise, I'm going to lower all attendees' hand, and then now can you raise your hand if you have worked done some hands-on PBPK, whether if it's with PKSIM or any other software? Okay, so it seems that it's limited number of people who have done any hands-on. I'm checking some of the name I know. Yeah, there are some people that I know who didn't raise their hand, and I know that they've got advanced knowledge in PBPK modeling. But I guess, yeah. But anyway, don't worry because we are going to start from the beginning. Yeah, and my last question is, can you raise your hand if you have already done some work, some PBPK modeling with PKSIM? Okay, so very limited. So you are in the right place because that's what we are going to do today. That's great. Thank you. Okay, Cleo, can you talk? Because normally I allowed you to talk. It seems you can't talk. Can you talk, Cleo?
I think I can talk right now. Yes.
Yeah, that's great. Okay, brilliant. So that while I'm presenting, if you can let me know if there are questions, that would be fantastic.
Will
So
do.
I'm going to share my screen now. Can you confirm that you can see my screen, please?
Yes, we can.
Thank you. Okay, so as I was mentioning, my colleague Carla is going to join in about an hour. And today we are going to discover PKSIM for the people who don't know it. So here is the agenda for today. So all the time are in Central European time because I know there are people on other time zone. And the time that I've shown here are approximates. So yeah, it will be more or less that, let's say. So what we are going to do, we are going to discuss about the objective. I'm going to talk to you about our company, general talk about the OSP suite, and then a very high level overview on PBPK modeling. Again, this is not a lecture on PBPK modeling, but just to make sure that everyone is on the same page. Then I will just spend a little bit of time on some elements that you need when you want to build a PKC model. And then we are going to see what the hands-on is about. Then we will spend the rest of the time, and you can see that really the biggest part of the workshop will be on hands-on, because I think that it's what makes people be able to work on a software is doing hands-on. You can see that there are some breaks that are planned, and in fact there are 2 breaks, but probably I will do 3. So I do short break, but I think it's important because it's quite demanding when you're learning new skills. So I like to have short breaks, so it will be 5 or 10 minutes depending on where we are in how we are progressing, but we will have some breaks, so don't worry, it will be fine. Again, it's important you're here, it's your time, it's your workshop. So if you have questions, please ask the question. There are no stupid questions, and be sure that if you're asking a question, other people will be wondering the same question and will be happy that you ask the question. So initially, Cleo will be able to tell me if there are questions because I can't see that on my screen. And then after that, Carla also will join and help with that. So please ask questions, and for those who know me anyway, you know that I'm going to stop from time to time and I'm going to ask you to raise your hand, stuff like that, to make sure that you are with me. So the objective for today is that by the end of the workshop, you will have a good idea on how to build a simple PBPK model in PKSIM following IV route of administration. You will have run individual and population simulation. you will have an idea on how to interpret the key outputs, and you will be ready to start investigating PKSIM further. Because starting with the PBPK modeling software is always a bit daunting. You know, it's not like Word or Excel, it's something a bit more complicated, so it can be a bit scary to get going. So this will give you your first step. And of course, if you want to investigate PKSIM further, don't hesitate to contact us. We'll be happy to help you in many different ways. And my objective for today is that you come out of the workshop having learned something, being happy that you spend this time with me, and being convinced that PKSIM is a good software, and that even though it's a free software, it's a good software. So before we get going, regarding the software, you should have installed version 12.1 or 12.2, depending on when you received the email telling you about the software. If you haven't installed it, it's very easy. You can go to the address that you see on the screen and you can install it. If you've got version 12, it's fine. If you've got a version below version 12, there has been a major revamping on the software, so you need to download version 12 or above. You also need to have the protein expression database, downloaded it, and installed it in your PKSIM. If you haven't done it, make sure that you download it, but if you haven't installed it, we can do it during the hands-on. The hands-on material, you will have temporary access just for 24 hours through the exercise that we are going to do together today. And you've got the address there, but normally you should have received it in the email that our marketing manager sent you. And then with regard to training, if you are in academia, you can get free access to our Talent LMS platform at the following address, and you've got access to all our online training. If you are in industry, you know, the software is free, so you will need to access it in the same way as the academia, but then you will need to purchase through our shop, and you've got the address here. There are four courses that are free for everyone, but if you want to do another one, which is not free, obviously you will need to purchase it. If you have any question, you can contact us on training@ESQlabs.com, and also you will see that you will get my address and Carla's address. And if you want also to keep in contact, you can also follow us on LinkedIn. You can follow ESQlabs on LinkedIn. Just to mention, the slides will not be available, but the recording will be available on YouTube. And again, I hope that the people who are recording the session stopped it, because it's going to become available to you. So the first, as I was mentioning, the first part will be a short introduction to ESQlab, to the OSP suite, and a high-level overview of what PBPK is and what we use it for. So ESQlabs. So first, where does the name come from? So Aesculapius is actually the Latin name of the god of medicine in Greek mythology. And if you listen to the sound, Aesculapius sounds a bit like Esculap. And so if you combine it with efficacy, safety, and quality, what you get is ESQlabs. So that's where the name is coming from. So ESQlab has been created in 2017, and now we are more than 45 scientists plus other administrative employees. And what is really nice is that we've got a very versatile expertise. We've got people who are biologists, pharmacists, or engineers, and programmers as well. And it allows us to have a very rich and versatile expertise in the team. We have delivered hundreds of projects, and I think this number should be increased because it's been there for a little while. And also it's a very fast growing company, because between 2017 and now, we went from 5 employees to more than 50 altogether. Our clients, we've got about 50% of the leading in pharmaceutical and chemical companies, and we've got a very strong relationship with regulators worldwide. So the FDA, the EMA, as everyone knows, and also for the chemical industry, the EPA, which is the US Environmental Protection Agency, and the FSA, which is the Food Standard Agency in the UK. So we've got really a strong relationship with regulators worldwide, and PKSIM is accepted for submission by regulators. So what we want to do, we want to empower drug development and chemical risk assessment. So it's not just pharmaceutical, but it's also chemical. And just one question, is there anyone who is working in the chemical industry, not in the pharmaceutical, but chemical? Can you raise your hand? Yes, so I see two participants. Okay, great. Yeah, and so what we do, we provide consultancy services and solution, and always with the idea of having mechanistic modeling at the center of what we do. So we've got 4 pillars in what we do. We've got model-informed drug development with PBPK, so physiologically based pharmacokinetic and quantitative system pharmacology. And we support drug development throughout from discovery through regulatory decision. Then we've got, and that's why it's more interesting for people who are working in the chemical industry, we were the next generation risk assessment, where the short name is NGRA, where we applied physiologically based kinetic, PBK, and quantitative system toxicology. And then a big pillar in the work that we do is the software. I mean, we don't own the software, but we are the main co-developer of the open source software with several programmers working for us and working every day on PKSIM and MOBI, which really places us in a very nice position to help people customize the software according to their need. We also provide training and workshop, and that's why you're here. And what we want, and it's really in our value, we want to empower scientists everywhere to know about PBPK and to use PBPK. And that's why we really believe in open source. So regarding model-informed drug development, so what do we offer? We offer PBBM, so we have expertise and we can help from the formulation design to the quality control. We also do drug development and animal safety with PBPK and QSP, and you will see when we do the example that we've got many species. I was going to say preclinical, but not just preclinical, but also veterinary species that we've got in the software. Of course, one very important thing is drug-drug interaction that you can conduct with PKSIM, and where we've got a big library regarding DDI. Then we've got special populations, and it includes pediatric, geriatrics, also pregnancy, and hepatic impairment and renal impairment. And more on the QSP side, we've got the disease, drug effect, and clinical trial simulation that we can do. And translational PBPK, which is to do first in human prediction. Regarding NGRA, what we do PBK and read across. Again, PBK for risk assessment for human and for the environment, and then QST and QAOP. So with regard to the software, before showing you our software offering for those of you who are really new to the OSP suite, I just want to show you that the OSP suite actually comprises 2 software. So it's PKSIM and it's MOBI. Today we are going to focus on PKSIM, but I'm just going to say a couple of words on both of them. So This is an open physiologically based mechanistic modeling platform, which has been developed and refined for 20 years. As I was mentioning before, we have people working on it every day, like for software for which you would pay. So actually, we do have people who work on the software every day to make it better. And as I was mentioning before, we've got many successful regulatory submissions worldwide, FDA, EMA, and other regulatory authority using PKSIM and MOBI. So, of course, what we offer regarding the software, the OSP suite, and also some air programming where we've got some package and some shiny app development. I mean, I don't know if you have followed us on LinkedIn. Now there is a little app that has been developed and which is quite nice. It's called caffeine.esqlabs.com. And it's not R, but it's a little app that has been developed by our software team, where you can actually enter the number of coffee that you're taking per day or tea, and also your age, your gender, and so on and so forth. And it's going to give you your caffeine level in your blood and tell you whether you're below the toxic level. So it's quite nice. So we've got a lot of things that are a bit more useful than that, but so our programming team really works a lot on our programming to increase the offering that we can have with the OSP suite. And with regard to the training, we've got some open workshops, but also we do some workshop as well, pre-conference a lot we do. And this year, for the first time, we are going to give a 1-week workshop in the summer, and I'll come back to that at the end of the workshop, where we are going to focus on MOBI. This is not a free workshop, obviously, but we are doing this type of workshop, and you will have the offering. Either you can have it on LinkedIn, but also at the end, I am showing you what is coming up. We can do also tailored training. That is, if your industry wants to have a training, a specific training on something, for example, someone is asking for specific training on virtual bioequivalence and IV/IVC, so we are going to do that. And then there is our online training portal, the Talent LMS. I showed you the address before. And so it's free for academia. And something that I forgot as well is that for low to moderate income country, there is a big discount on the prices that are in the Talent LMS. Because again, it's really in our value for people to be able to be trained and to use the PBPK software. So what do we have? What are the framework and the tool that we can offer to help to support scientists in the chemical and drug assessment? So we've got library, workflow, and database, and I'm just going to go through that relatively quickly, but just to give you an idea. So one thing which is important to us is women's health, and it's something that we are quite proud about. I mean, it's being discussed more and more that women's health has been a bit left on the side because for cultural reasons, but also women were not included in clinical trial, and also because it was thought that women's health was the same as men's health, and more we realize that it's not the same. And for the moment, what has been developed by ESQlabs is modeling pregnancy, lactation, female reproductive tract, menstrual cycle, and menopause. So we can help you if you are working in that area. Of course, you can develop model for biologics, so large molecule. We are not going to see that today, but it's something that you can do. And we've got some people who are specialized in that. And you can do bispecific antibodies, conjugated drug, gene therapy, etc. Of course, and that's good that we're doing that. We've got small molecule and chemicals, as I was mentioning before. Then we've got also some people who are the expert in radiopharmacology, and we can do PBPK-based dosimetry for radioligand therapy. Then one of our business unit is working on microphysiological systems, so MPS, and we've got a platform that can help. So it's organ on chip, and it can help also to reduce. It can help to have parameters for the PBPK model, but also to reduce the use of animal, which is something which is close to our hearts as well. As I was mentioning, we've got some disease model and toxicology model. So we've got diabetes, oncology, hematology, liver disease, also drug-induced liver injury, cardiovascular model, and ocular contraception. So a lot of models. And this is done in MOBI, and you will see later on the flexibility of MOBI allow us to do quite a lot of things with that. Then we've got high throughput screening and that made PBPK, which allow us to integrate automatic PBPK model development for high throughput pharmacology and safety screening. And then finally, we've got IVIVE toolset with workflow to leverage the in vitro computational model for IVIVE PBPK and to allow us to do first in human prediction. We are also working as well on some tool set for PBBM. Are there any questions regarding what I presented so far? Okay. So then I'm going to continue on the Open System Pharmacology Suite. And I just have a couple of slides on that. I don't want to spend too much time, but I think it's important. So here you can see the first page that you see when you go on the site on the web, where it said that it's qualified and accepted by the scientific community, and it's available free to everyone. So I think it's very important. And before I worked for ESQlabs, I had the misconception that because the software was free, it couldn't be good. And I was wondering how they could manage to have something good if it was free. And actually, I've been working there for 9 months now. And yeah, it can be free and good at the same time. So here you've got the address that you need to follow, but most probably you've already been there to download the OSP suite. And here on the slide, it's a community more than just a software. And it's true that there are a lot of interaction because the way that the software is developed and also that we see what needs to be developed is through the forum and people interacting and asking questions. And also in there, people are sharing models or module of models that people can reuse. So after that, there is the question of the validation, but at least you've got some starting point. And depending on how you look at the model and module, you can see whether they've been partially validated or fully validated or just a starting model. And then also you can find some extensive documentation on what is available in both PKSIM and MOBI. So just one more slide, and you can see here that you've got the address as well that you can follow if you want to go and see the roadmap. I'm not going to read that, but again, you know, the vision is what we saw on the first page, but the mission for me is really very important because it says that it's promote the idea of pre-competitive open collaboration for the advancement of modeling and simulation science in pharmaceutical and life science. And I think it's very important because it's really promoting the idea that if we can work together on things where we are not in competition, we can make sure that we are developing the PBPK science and that we are all moving in the right direction. Of course, we are not going to share things that are IP protected, but we can work together to increase the knowledge in that field. Okay, so I saw that there are a lot of things in the chat, so I hope that it's not question.
Yes, there's one question, Natalie.
Yes.
If we will also run a similar introduction workshop about Mobi instead of PKSim.
Okay. No, we are not doing a free workshop for Mobi. So with regard to Mobi, yeah, in a couple of slides, I'll come back to that question in a couple of slides.
Great, thanks.
Yeah, because really the two next slides are talking about PKSim and Mobi, and then I'm talking about learning each of the software. So it's very timely. Thanks, Cleo. So as I was just saying, so I'm going to tell you what PKSim and Mobis are. So PKSim is an intuitive PBPK model builder. And the advantage is that it's easy to use. So easy to use, I would put it in bracket, relatively easy to use, because as I was saying before, PBPK software is not Excel, so it's something which can be a bit daunting at the beginning when you start using it. For people who have used GastroPlus before or GPX, let's say, I would say that it's going to be relatively easy to switch to PKSim because it really seemed, and you will, I'm sure that you will share my assessment, that it seemed that when Simulation Plus decided to move to GPX from GastroPlus, they inspired themselves by the design of PKSim. And you will see why I'm saying that when we are doing the hands-on. And it's also because models are created from predefined blocks. So you're creating blocks, so you're creating your individual, your compound, your formulation, your administration, and then you combine everything together to do your simulation. So very similar to what GPX decided to do recently. Comprehensive database of physiology knowledge, so that's the advantage of all the PBPK software, is that here because of the way that PBPK works, it's mechanistic, and you've got a lot of knowledge, and every time here we are at version 12, so every time there is more knowledge in the public domain, it's implemented in the software. And then you can have a lot of knowledge about enzyme, about transporter, about flux, about the physiology, anatomy, etc., which is excellent. So one drawbacks regarding PKSim is that it's a gray box approach. It means that you've got quite a high level of abstraction and you can't see all the parameters and formulas and you can't edit a lot of them. I mean, there is a way around it by going through Mobi, but directly in PKSim, it's not something that you can do. So if we move to Mobi, then Mobi is an advanced modular modeling tool. The advantage, and I was alluding to that in the previous slide, is that you can access almost all the parameters and formulas within the model. You can also easily reuse models that have been built or modules. And again, I was saying on GitHub, for example, you can find some modules. And some of the modules that we've been, for example, with the Gate Foundation are available for you to use. They've been validated and you can just use them. So it's nice. And then also, contrary to PKSim or to other PBPK software, you've got really unlimited flexibility. And that's the big difference with PKSim is that you're not limited to certain predefined blocks. And anything that can be described by an ordinary differential equation can be modeled and simulated in Mobi. But of course, and that's coming back to the question that Cleo asked, these come with a price because there is no wizard for easy creation of model structure. And then the learning curve is very steep, okay? So when you want to learn PKSim, if you follow this workshop, then you do a couple of more of the online training, then it's relatively easy to manage to be comfortable with PKSim by yourself. For Mobi, I think it's much more difficult. So that was also one of the reasons why we decided to do this 1 week training at the end of June because we think that it's really something where you need some time to get familiar with MOBI and so on, and with the way that it thinks in a way. So to come back to Cleo's question, so no, we are not offering a free workshop on MOBI. You will see that there will be some in the QSP conference in Leiden at the end of April. There will be one-day training on MOBI. It's not free. So it's something that we can do, and probably at Page, it's likely that we will also have a workshop on MOBI, one-day workshop, but we don't offer a free workshop on MOBI because it's less straightforward than PKC, let's put it that way.
Thanks for answering, Natalie. There are two more questions regarding MOBI.
Yes.
Is MOBI also free software to install?
Yes, absolutely. Everything is
and is introducing custom and/or overwriting existing ODEs? So can this only be done via MOBI?
Can you repeat the question again, please?
It was like confirming and confirming question. So introducing the custom and/or overwriting the existing ODEs, it can be only done via MOBI, right?
Yes, yes. I mean, yes, definitely. Yes.
Okay, thanks.
Thank you, Cleo. Okay, so just to recap a bit what we said, so the possible application in the pharmaceutical field is, of course, modeling of small and large molecule, species extrapolation, so first in human prediction with in vitro, in vivo extrapolation, spatial population, parent metabolite study or drug-drug interaction. We wrote it that way because you can model, of course, the metabolites if you are doing drug-drug interaction, but it's also applicable for prodrugs. Then PBPK, PD, or disease modeling. And finally, formulation, meal effects, and PBBM, and of course, toxicology. Are there other questions on this first part before we move into the overview of PBPK? Okay. Okay. So it seems that a lot of you know about PBPK, but some don't. And again, this workshop was basic PBPK, but it's always good, I think, to refresh, even if you've got some knowledge. So if you look at the definition from the European Medicine Agency, and I choose that one because I really liked it. So it said that PBPK modeling is a mechanistic modeling approach that integrates drug-specific data with system-specific physiological parameter to simulate the absorption, distribution, metabolism, and excretion of drugs in human or animals. I highlighted in blue all the words that were important. So you've got the drug-specific, the physiological parameter, but the very important thing is the mechanistic modeling, because before moving into PBPK about 10 to 15 years ago, I was doing some, let's say, classical modeling, so individual modeling or PBPK as well, which is also very interesting. But here, really, the difference with PBPK is that it's mechanistic. So we are trying to understand, based on the physiology and on the drug-specific characteristic, why the pharmacokinetic is behaving the way it does. And there is also, for the people who are more in the chemical industry, there is the definition from the US Environmental Protection Agency, so the EPA, which I like, is the PBPK models are mathematical description of how chemical, so it's generalizing, so it's not just drug, enter the body, moves between tissues and blood, and is metabolized and eliminated. And I like that because I think it really generalizes what PBPK is, and it's accessible to everyone. I think the only thing that the EPA definition is missing is really the fact that it's mechanistic again, and I think it's very important. So the way that it's represented here, you can see that we've got the organism. So here it's a human, And you can see that it's represented with many different compartments. The compartments are representing either tissue or organ or part of an organ, for example, for the intestine, and with connected with blood flow, etc., etc. So the difference with, I always say classical PK, but with compartmental PK, is that in compartmental PK, you've got 1, 2, 3 compartments, but they are not necessarily related to the physiology. Whereas in physiologically based pharmacokinetic, which the name says it all, it's really related to the physiology. And here, if we zoom in one of the organ or one of the tissue, then we can see that each compartment or organs is divided into 4 subcompartments. So you've got the red blood cell, the plasma, the difficult to pronounce, interstitial compartment, and then the intracellular space. And if we zoom into the gastrointestinal tract, the way that it's represented in PKSIM, you can see, I'm not going to go into all the detail, but here you can see that it's divided into 12 compartments going from the stomach to the rectum with specific properties for each of the compartments. And you've got varying properties. So you've got 5 compartments in the small intestine, and then 5 as well in the large intestine with varying properties, and you can read what they are, and they are important to explain how the drug is moving into that. And also you can see that here we've got explicit representation of the mucosa, which itself is subdivided into the enterocyte, the interstitial, and the vascular space. And this allows us to account for CYP distribution, so enzyme distribution, and also transporter distribution. So when we want to build a PBPK model, what do we need? So we need some data to inform the building blocks. Again, the building blocks are a bit like Lego that you are going to prepare, and then you're going to choose which of the Lego blocks you want to put together. So first, you've got the organism properties. So it's anatomy and physiology, and you can see here you've got volume, surface area, blood flow, etc., etc. So this part you don't need to worry about because it's included in the software. That's the advantage of using a PBPK software. Then you've got the drug properties. So some of the drug properties that are very important are the lipophilicity, the molecular weight, the pKa or pKb that allows you to know whether your drug is going to be ionized, and also some information regarding the solubility. So often people are asking, can we do without any properties? Yes, you can use a quantitative structure-activity relationship, but there are some basic properties that are very important to have, and these are this one. And then normally when you develop a drug, it's property that you should be able to have without too much difficulty. And if you don't have them, if you rely only on quantitative structure activity relationship, you're increasing your uncertainty regarding your model. And now you can see also that we've got anatomy and physiology, and you can see that it's ranging between blue and green. So why is that? It's because it's properties that are both depending on the drug, but also on your organism. So you can call them either hybrid ADME parameter, mixed parameter, system-dependent drug parameter. They've got many different names. But just to give you an example, and I think it's easier to understand that way. For example, if you take the fraction unbound for a compound, it depends on the compound, of course. But if you measure your fraction unbound in human, then the fraction unbound in dog is going to be different. It means that these properties depend both on your compound and on the physiology that you're considering, so on the species that you're considering, and children versus adult, etc. So the drug properties and the mixed parameter are information that you should provide. And again, if you don't provide them, if you rely on QSAR, then you are increasing the uncertainty in your model. And finally, what you need to have as well is a study protocol and formulation properties. So it's which formulation you want to administer, how you want to administer it, and whether you've got food intake and special events that are going to be included into your model. These are also things that you are providing, but usually it's not this part which is the most difficult to get. Okay, any question on that part?
Yes. One of the questions if we can change the expression if we're simulating for a specific population.
Sorry, can you repeat again?
Can we change the expression if we are simulating for a specific population?
I guess the expression, I guess it relates to transporter or to enzyme, most probably. So yes, you can. And also you will see that in the software, we already have different populations. And we are also continuously working on new populations so that directly in the software, you will have the different population. But if the population that you're considering is not in the software and you want to modify some of the characteristics, you can do it.
Thanks. And do you have enough regional physiological data for transit times, pH, fluid volumes, etc., enabling compartmentalization of human colon? If I counted correctly from the slides, 4 or 5 regions.
Yes. And I know that when I was working with GastroPlus, that the colon was not that differentiated, let's say. So, I mean, this is based on publication, but knowing whether we've got enough things, I would need to double check, but that's something maybe Cleo, if you can make a note, then we can double check on the documentation. But normally, if it's in the software, it means that it was found in the literature, yes.
Yeah, so it's coming from this Taylor paper that is going into the whole GI tract, and the colon is divided into indeed 5 different regions. So the ascendus, transverse, sum, descendus, sigmoid, and the rectum.
Thank you, Cleo. Thank you very much.
Then there's one more question. If we don't have the KM and the Vmax, can we predict using PKSim?
If we don't have the KM and the Vmax, if the question is whether we can predict the KM and the Vmax using PKSim, if you don't have any information, it's going to be difficult because you will have some identifiability issue. So you would need to have some information. And probably you will need to enter it as a clearance, but then it will be difficult to account for non-linearity. So I'm not sure that if you don't have any information, it's going to be possible. Unless you've got literature data that are with compounds that are similar, but it's going to be difficult. Cleo, any idea about that one?
No, I think you're fully correct on that. That you need that information, and that fitting can be done in R, but not in PKSim.
Yeah.
Then one more question. Can you please elaborate on the differences between classical modeling and PBPK, and also on the part that PBPK is mechanistic technique?
Yes. So what I call classical or compartmental PK is you've got different type of analysis that you can do. So non-compartmental analysis. So here you don't have any compartment. You're just modeling the elimination rate, and that's it. But otherwise, you've got some compartment And it started already, I think, in the 1930 or 1950, where you could describe the concentration versus time profile using different compartments. But again, the compartments were just empirical compartments, and they didn't have necessarily a physiological meaning. Okay, and it was so it was 1, 2, or 3. It started with 1 and 2, and then it could be also 3. And it really depended on how your compound distributed. But again, we've got much more than 3 organs in our body. So it was just empirical to be able to describe the concentration versus time profile. Here, when you do PBPK modeling, it's different because what you want to do, you want to go from the physiology and from the physical. So it's bottom-up approach. So you want to go from the drug characteristic and the physiology of your organism that you're considering, whether it's a preclinical species or human, to try to predict what is going to happen based on the information that you have. And after that, you are going to compare, and that's what we're going to do also in the enzyme. So you are going to compare that to your observation. Whereas in classical modeling or compartmental modeling, you're going from your observed data to try to find a model that fits the data. So that's, how would you say, top down? Is it top down? Top down approach? But what we're doing here is bottom up. So you can predict without having any observation. But I mean, it's always better to have some observation because then you can see whether your model is predicting okay or not. I hope that answered your question.
No answer yet in the chat, but yeah, yes.
Okay, great.
There was also one more question still before.
Yes.
If you could give any more comments, any other comments about the veterinary use?
Excuse me, repeat again.
If you could give any more comments about the veterinary use of OSP.
Okay. It's just that you can, for people who are doing veterinary drug development, we've got also the organism. And I mean, I can just show you the drop-down menu when we go through the enzyme. So we've got different species that can be used if you want to know when you do veterinary development, you want to know also what's happening in the body. So you can do prediction in dogs or cats as you would do in human. Does it answer your question as well?
Yes.
Okay,
Thank you.
Great, brilliant. Okay. Okay, are there any other questions?
No, that was it.
Okay, brilliant. Okay, so now I'm going to show you, so you can see that I opened PKSim. If you want, you can also open it because anyway, you will need to open it soon to see what are the important elements to build and just to give you a first orientation about PKSim if you haven't opened it before. Okay, so I'm not going to go into very, very much detail, but just so that you get an idea. So I've opened PKSim, as you can see, and first you can see that here you've got a menu and you've got the file where you've got if you want to create a new project, and probably you saw that I had an old project. I mean, it was just, I was practicing the hands-on, and so it was obviously no client data, it was really the hands-on that I was doing. So you saw the end of the hands-on, but so if you want to open a new project, you just click on new. If you want to open an existing project, you click on open. And in recent documents here, you don't see anything. But when you will work in PKSim, you will see that you will have the 10 latest model on which you work that you open. So it's quite nice because then you don't need to go and look for a project because it will be available there. Then you can save your project and save or save as. And then I'm not going to go into the detail of all that. because some are a bit more advanced, and then you can exit the application through the exit. You can see also that here you've got some icons, and here you've got the building blocks explorer, where I've got my mouse at the top, and down here you've got the simulations explorer. Okay, and actually the icon that you've got in the ribbon at the top are the same as what you've got in the building blocks explorer, and some are the same as what you've got in the simulation explorer. For example, the parameter identification and sensitivity is the same as what you've got in the simulation explorer. And whether you want to use the ribbons or the building blocks explorer is really up to you. That's not a problem. You do what you prefer, and you don't. You're going to arrive in the same place. I mean, I've been used to working with the building blocks explorer, so that's what I'm doing. But I mean, feel free to try to use the ribbon. That's absolutely fine. So again, as I was saying, for the people who have used GPX, you can see that there are some similarities. Yep, some similarities. And the way that we are going to work is that we are going to go down the building blocks, almost all of them. But you will see that at some stage I will say we're not doing that now. And then once we've built our blocks, as I was mentioning already, that repetition is pedagogy, then you're going to choose the building block that you want to include in your simulation. Then what else? Yeah, you can do some comparison, but we're not going to do that today. I mean, obviously, in 4 hours, we can't do everything. But again, that's something that you can try doing. With regard to the access to the example, I hope that you were able to access it. You will have access until 8 p.m. tonight, Central European time. So if you want to redo the example or do something, and as I was mentioning before, you also have 4 training that are available without free of charge, let's say. Yeah, for the other thing, they're a bit more advanced. The utilities is something that we might see depending if everyone was able to put their protein database, but otherwise that's it. I don't want to go into more detail. Any questions on that part? But don't worry, I mean, also, I'm sorry not to let you think, but we are going to use a lot of the building block, the simulation, the sensitivity analysis, and so on. So it will become easier when you practice. But anyway, if you've got a question, please feel free. Okay. So I guess there are no questions. So I'm going to come back to the presentation of the hands-on. So the objective of the hands-on obviously is to give you an introduction to PKSIM so that you feel comfortable afterward to go and work on it by yourself. Understand the key features and understand how to build blocks and so on. Understand also the physical-chemical and ADME properties that are needed in a PBPK model. And we are going to perform one sensitivity analysis, so acronym SA of the model. We are going to do some parameter optimization in the model, and I'm going to repeat that a couple of times. In PKSIM term, it's called parameter identification. So optimization in PKSIM is parameter identification, little name PI. Then we are going to compare the simulation results with observed data. And finally, we are going to perform a population simulation. So normally we should have more than enough time to do everything. If not, I prefer to go, at a pace to have everyone with me and then not to finish everything, but normally there shouldn't be an issue. So far, every time I've given that workshop, I was able to finish. But again, I'm not going to rush. I prefer that people understand that we do rather than rushing through the different steps. So the molecule that we are going to use is midazolam, and you can see here the structure. So when you've got the chemical structure of a compound, I would always recommend that you have a look at the structure before going further. It's the same. Have a look at your concentration versus time profile. It's the same. So here we can see that the midazolam has got many cycles. So probably it's lipophilic. It's got some nitrogen, and so maybe it's ionizable. And then something which is important in PKSIM, and I will explain later why, is that it's got some halogens. So they've been highlighted in blue, and so it's important. So we think probably, as I was saying, lipophilic, probably ionizable, and with some halogens. And just for your knowledge, so midazolam is used in anesthesia, in sedation and anxiety, and also end-of-life treatment. I mean, that just for your knowledge, that's not going to be used in the PBPK modeling. Important parameter for us to input into the software is that it's a small molecule. It's not a biologic, and it says yes, and you will see when we do actually the enzyme that there is one place where you need to say whether it's a small molecule or not. We can see that the lipophilicity is quite high. It's between 2.9 and 3.9, so we've got a range of value, and that it binds quite heavily to albumin because the fractional band is pretty low. And here again, we've got a range of fractional band. It's ranging between 1.6 to 2.4%. So very low fractional band, which is something important to remember. Then the molecular weight, you got it there. And then we've got two halogen, one chlorure and one fluorure. It's ionizable, as we saw, based on the nitrogen, and the pK is 6.15, and the solubility is pretty low at 9.87 milligram per liter, and the reference pH is 7. So how is it metabolized and excreted? So it's through CYP3A4 and renal clearance. So you will see in the example, the way that we are going to do is that we are not going to introduce the enzyme directly. First, we are just going to introduce the renal clearance, and then we'll enter the enzyme. So it's just for the reason of teaching. But in real life, if you know that it's going to be metabolized by CYP3A4, you would enter it directly. Okay, you would enter either if you got the information regarding the Vmax and Km, you would enter it directly into your model. If you don't have the information, you would enter it as hepatic clearance, but you would enter it. But in our example, and just for pedagogic reason, we are going to do it stepwise. Okay, so we are going to take a break in a minute. So are there any questions before we take a break?
One of the questions was, when is the break? So that is answered.
Yes. I'm going to try to have a short break every hour, because again, I think it's brain demanding, so no problem. No other questions?
I think no. Oh, there's some question coming up now. For the
Okay.
metabolism, we only need to know the metabolization by CYP3A4 or also by other CYPs?
For midazolam here, we say that it's only CYP3A4, but for your compound, if your compound is metabolized by other drug than CYP3A4, yes, you would need to know by which enzyme it's metabolized, yes. But again, also something that you need to take into account is that you always need to think about the parsimony principle. Parsimony principle, that your model should be as simple as possible, but as complicated as needed. What I mean is that if you've got, let's say, 3 different enzymes, it may be difficult for you to be able to identify, to parameterize all your enzymes based on 3 enzymes, for example. So if you see that it's mainly metabolized by one enzyme, then maybe you're just going to include that enzyme and not the other. But it comes with experience when you decide to do one or the other. Does it answer your question?
Yes. Thank you.
Okay, great. Any other question?
If solubility for a chemical is not available at a reference pH, that's the question. I guess what to do then?
Okay. Alors, if you don't have any information regarding the solubility of your compound, it will be a problem. I mean, to be honest, I don't know how you would do with that. But normally, even when you are in early development, you will have some information. You may not have all the solubility that you need, but most of the time, even in discovery, you will have some information regarding the solubility. And if you're working on a generic or something like that, then in that case, you can find it in the literature. But I don't think that you would have absolutely no information about the solubility. If you've got no information about the solubility, I think you will need to run at least one experiment to have some idea about it. What do you think, Leo?
Yes, and you could also alter the pH. So if you have a pH on a different, the solubility on a different pH, then you can also implement
Yes.
it in the compounds.
Yes. Sorry, I misunderstood the question. Yes, you can have any you as long as you've got some solubility and the pH doesn't really matter, because you will see when we enter also for the midazolam with the pKa that we can get a curve of the solubility versus pH, and it will be more or less accurate depending on the input that you have. But I saw that what do you do if you don't have any solubility at all? That was my understanding. Okay.
Is it also possible to predict the solubility from a melting point?
That I don't know.
Me neither.
Okay, but maybe we can have a look in the documentation and then come back to you. I've never heard about that, but maybe we can have a look and come back to you on that one. Okay, great.
There are a couple of more questions.
Okay.
If you have a single value for the phys-chem properties, I'm interested to find out how we handle a range of values, for example, for log P and fraction and bounds.
Okay. So let's park this question for the time being, because we are going to do the exercise, the hands-on, and I'm going to talk a bit about that when we do the hands-on. So please park that question and come back to us toward the end of the hands-on. If we haven't answered that question through the hands-on, then I can elaborate on that. Is that okay?
Yes, that's also what was already assumed in the question, that it will be handled after the break. So that's perfect, correctly assumed. And then there's one more attendant that has some technical issues with OSP.
Oh.
The OSP does not open, says I have to repair.
Oh, okay. So, can you try to remove it from your computer and try to install it again? And can you do that during the break, and then we'll see after the break. But I mean, regarding that, I may not be able to help you. But if you can maybe send us a screenshot also about the problem that you have, and then we can contact our IT person to see whether he's got an idea. But I think first thing is deinstall it and then remove it from your computer and then reinstall it. Normally, it shouldn't be a problem. Sometimes there are people who have problem with their company not allowing the installation, but here it doesn't seem to be that case. So if you can do that, that would be great.
Yeah, it will be tried during the break. And maybe as a backup, indeed, someone else also saying the portable version.
Yes.
We could try.
Yes. Thank you. And really thank you to all of you for your participation and for your engagement. It's really nice to see that people are, listening and taking part in the training. That's great. Any other questions?
I guess not.
Okay. Okay, so it's 10 or 9 past 10, let's say. So we are going to take a break until, so we're going to take a 10-minute break because I think we need it for our brains. So we'll come back at 20 past 10. Make sure, so in 10 minutes, because depending on your time zone, so make sure to come back on time, please.
Okay, see you.
See you. Okay. So it's 20 past 10. So before we get going with the example, I would like for my colleague Cleo and Carla to introduce themselves. So Cleo, do you want to introduce yourself?
Yes, thanks. Yeah, so hi everyone, now also with camera. I'm Cleo, as Natalie mentioned. I joined ESQlabs in December. And before that, I did a PhD, a full PhD working with OSP. I focused on special populations, so obesity and older adults. And yeah, now continuing that work at ESQlabs.
Thank you, Cleo. Carla?
Hi everyone, I'm Carla, and yeah, I've been working at ESQlabs since 2 years now, where I mostly work with large molecules PBPK modeling, and really happy to be here this morning.
Thank you, ladies. Okay, so we are going to get going. So I hope that the person who had the problem was able to solve that issue. If not, then you will see that at some point in the example, we've got some catch-up point. If the problem is still not resolved, then maybe Carla or Cleo can contact our IT person to see whether there is a possibility to help you. I want to get going because we've got a bit of things to cover. And again, I'm going to do again 1 or 2 more breaks because I think it's brain demanding. Okay, so I hope that everyone has opened their PKSIM. Can you see my PKSIM?
Yes.
Okay, thank you. So as I was mentioning, the first part of the example will be for us to define our building blocks. And so that's what we are going to do. As I was discussing again, we are not going to include the enzyme at this time. We are going to define the building blocks, and then we are going to run a simulation and then compare it to the observation. So it's pretty straightforward. You will see it's always the same. So we're not going to define the expression profile because the expression profile is for the enzyme. But apart from that, we are going to go down the building blocks. So if you go in the individuals building block, and you do a right click, you can see that you've got 2 options. You're going to click on the add individual. And you need to give it a name. So we are not going to be very creative. We are going to call it standard name. You can call it anything you want, but we are going to call it standard name. And for the purpose of the example, we are not going to change anything. We are going to keep the default, so European male and with a 30-year-old, 73 kilogram, and a BMI of less than 24. So we're not going to change anything, but you can see that here, if you want, you can change things. In the anatomy and physiology, we're not going to change anything. And again, as I was mentioning before, good working practice is not to change anatomy and physiology unless you really need to. Often when people start doing PBPK, if the model doesn't really fit the data, then there is a tendency to try to optimize a lot of things and also to modify the anatomy and physiology. But you shouldn't do that unless you've got a good reason to do that. So you should do that at the last resort if you didn't find anything else that work. Again, if you click on next again, then it will be to add the metabolizing enzyme, and you can see also we can add other things, but we're not going to do it now, as I was explaining before. So you just click on OK. And now we can see that in our building blocks explorer on the left-hand side, we've got the standard male, which is there, and you can see the detail when you hover over it. We are not going to build a population now. It's something that we will do at the end of the example. So we are going directly to the compounds building block, and similarly to what we did, right-click, add compound. And here the compound that we want to build is midazolam. So you just type midazolam at the top. Voila. And what I was saying before is small molecule. So if you're working on the biologics, like Carla does usually, you would uncheck this checkbox. But here it's a small molecule, we know that. And if you remember, we saw that the range in lipophilicity was 2.9 to 3.9. So here, arbitrarily, we are going to enter 3.9. I mean, if you prefer, you can enter 2.9. And the example is going to be similar anyway. You will see that we will go through the same step. And it was a question regarding how do you deal with a range. So here I'm following the example. Probably if it was my project, probably I would take a value in between. But here in the example, we say 3.9, we take 3.9, but it's okay. It's not going to change the outcome of the example. We are going to arrive in the same place. Good working practice is here, you've got the value origin. So value origin is where your value is coming from. So whether it's coming from a publication, then you should probably write the name of the publication so that you can retrieve it. And if it's coming from an in vitro experiment, then write the name of the report so that you can retrieve it later on. Here we don't have any information about it, so we're not going to write it, but it's a good working practice to do that. So by default, you've got the albumin. If you remember, midazolam binds to albumin. If it was binding to alpha-1 acid glycoprotein, we would click on that one. Or if we don't know, we would click on that one. But here it's albumin. If you remember, we had a range as well here for the value. And in the example, we say, okay, let's take 1.6%. So you can enter the value here. And you can see that you've got 2 units. Either you can enter it as a fraction or you can enter it as a percentage. For me, I usually prefer to enter it as a percentage because when it's a very small percent, it prevents me from making mistake with the zero. So it's 1.6%. And if you want to enter it as a fraction, obviously it will be 0.016 and not percent. So again, if you've got the value origin, you write it, we don't have it there. I'm just waiting to make sure that everyone is with me. And now we're going to enter the molecular weight. So the molecular weight is 325.77. Someone raised their hand.
Yes, there is a question if we can upload already from an already prepared compound file.
Oh, yes. Yes, you can do that. But here the purpose of the example is for people to know how to build a model, but you can load from a template or from a module or for a compound. Yes, definitely.
Thanks.
You're welcome. So as I was mentioning before, as halogen, it's important to say whether it has halogen. And if you remember here, we've got one chlorure and one fluorure. So you need to click on the drop-down menu, and then you add one for the chlorure and one for the fluorure. Difficult to pronounce. And you can see that you've got something which is called the effective molecular weight, which is below what the real molecular weight is. So what it's used for, it's because we've got some quantitative structure activity relationship to calculate the permeability based on the molecular weight of the molecule. But the halogens have an impact on how the equation works. And so there is a need to decrease the molecular weight if you've got some halogens. And if you do the test, you can see that if you've got a bromure instead of chlorure or whatever, the effective molecular weight is going to change a bit. But so it's so that the equation is applicable, then you need to define the halogens. We saw also that we've got a PKA, basic PKA, which is at 6.15. And again, you can see that everywhere you can enter where your value is coming from. And then here we are going to enter the value for the solubility at the reference pH 9.87, and the reference pH is 7. Make sure that the units are okay. I mean, here they are the default units. One thing that I want to show you as well, because I think it's interesting, is that here you've got the solubility gain. So the solubility gain is the difference in solubility between the non-ionized and ionized form. And here I'm going to show you the graph. Voilà. So one thing which is important here, it's a default value. And you should be able to determine your solubility gain if you've got your solubility versus pH profile. Here, it's a default value, so it's not a true value. In our case, it doesn't matter because anyway, we are via IV route, so it doesn't matter. But in your case, in a real case, if you've got an ionizable compound and you want to have the solubility gain, you will need to have more than one value for the solubility, and you will need to have an idea about the solubility versus pH profile. But I thought that it's interesting to show that so that you can see how the solubility behaves across the physiological pH. Okay, then we are going to click on next. And we're going to move to the Admit tab. Okay, so now what we are going to do, and that's what I was explaining before, for the first part of the example, just for teaching purposes, we're just going to add a renal clearance. So you click on the renal clearance and you do a right click and you do add renal clearance processes. Here, the data source, we don't have a source, so we are just going to put assumption. Or you could put non-applicable or whatever. It's in human, so the species is in human. And then the process time is glomerular filtration. We are going to assume that because it's a small molecule, it's freely filtered in the kidney. And then we're going to click on OK. Then if we click on next, we are going to the advanced parameter. So I just want to show you, we're not going to do that. So the top part where I've got my mouse is for oral formulation that you can use for oral formulation. And then the bottom part is when you've got biologics. We are not in that case, so you just click on OK. We don't need to change any value. Is everyone with me? Can you raise your hand if you are with me and if you manage to create the building blocks? Okay, great. Brilliant. Okay, so we are going to continue with that.
There's one more question.
Okay.
Do we need to change the GFR fraction?
No, actually here we assume that midazolam is freely filtered, and so we don't change it.
Okay, thanks.
Okay. Yeah. So here, normally we would go to the formulation, but here, because our formulation is very standard, we don't need to create it because it's already in the software. So we are just going to go to the administration protocol. Okay, so we are in the building blocks area on the left-hand side, right click on administration protocol, and as before, add administration protocol. So we are going to give it a name. The name will be IV midazolam. It's intravenous bolus route, and the dose will be 5. You need to change the units on the right-hand side. The units here are in milligram per kilogram, which is useful for preclinical species or pediatric. But here we are dosing in absolute dose. So click on the drop-down menu and then click on milligram. And then you can see when you've got the drop-down menu that you can also have milligram per square meter, which can be useful when you are working in oncology programs. Okay, so 5, and make sure that you change to milligram and not milligram per kilogram. Otherwise, the dose is going to be very big. Then you click on OK. And voila, it's already done. The protocol. Okay, so now you need to download the, I hope that I can do that with you. Let me know, I'm going to share that. Can you see the talent elements on the screen or not?
Yes.
Excellent. Okay, so that's great. I'm not going to do it all because I'm in a virtual machine, so it's a bit different. But so what you need to do, you need to click here on Files, and then you will be able to download your observed data. Okay, so you just click on File, download your observed data, and then it will be a zip file. So you need to extract all so that you've got your data unzipped. Is that clear to everyone? I will assume it is.
Someone missed this part of the preparation, so it's not in the Learn platform or any other source for this file.
Excuse me?
Two
Someone
people.
is not in the Talent LMS.
Yes, and one other also asks for the link to download the file.
Okay. Cleo or Carla, can one of you send the zip file maybe through I don't know if it's possible to do that through the chat?
Yeah, we will try.
Okay, if you can send the zip file, or otherwise if you can send the link to the talent elements. But normally you should have received an email with all the detail regarding that training. And in that email, you've got the link. So the email was sent by ESQlabs or via by suddenly I can't remember Monique's name. What is Monique's name? Cleo, Carla, what is
Monique's last name? Monique
Yes.
Fontana.
Yeah. So I love, yeah. Did you manage to copy it?
Not yet, but someone else also says that we can only download Excel files. Other files are not opened.
Yeah, but it's okay
The
because
Excel file is enough, right? Yeah.
yeah, it's the Excel file that you need. The other file, the other file are catch-up file. So it means that if you're lost in the example and you want to catch up, it's something that you would need to open in PKSIM. So you would need to do File, Open Project. Okay, so it's catch-up file. The only thing that you need now is really the data.xls file. Okay. So does everyone has got it? Carla or Cleo, have you been able to share the zip file or the link?
No, sorry, as a panelist, I can answer only in Q&A and I cannot write it in chat, so.
You cannot write in the chat?
No. Just Q&A. So if you have questions, please.
Ah.
By the way, there was also a question about inhalation.
Yes.
In the chat if it's feasible. So I don't know if you want to answer or. So
I think, yeah, for what was
is it also possible to predict the PBPK of inhalatory drugs? I'm not seeing the option under the administration type. It's because you need to create a formulation, and we have a course for this.
Yeah.
I can put the link in the, well, yeah, we can send the link.
So Carla,
yes,
you don't have access to the chat.
No, only Q&A, but like usual, right?
Yeah, but before that, people didn't have access to the chat, and now this time people have access to the chat. So, okay, Cleo, have you been able to provide the zip file or not?
I send it in the chat.
Okay, brilliant. Thank you.
It's called data.
Yeah, thank you. So, yeah, Carla, at the next break, I'll check. Normally, you should be a panelist as well, so you should have access. I don't understand. But so anyway, so now everyone has got the observed data. So make sure to put it somewhere where you can access it. And now we are going to add the observed data to our building blocks. So you can see that we've got the administration protocol, then events, we're not going to deal with that today, observers neither, and then observed data. So what you do a right click, and here you can do either add observed data or add observed data for. You will see that in the example, it's written add observed data for midazolam, but in fact, in our case, because we've got only one data file, then we can use the first one. But you can do whatever you want, it doesn't matter. So for me, I just put it on my desktop. And so I've got the data.xls, you can see it on my screen. And then I'm just going to open it. And now you can see that a new screen open. And what we need to do now, we need to map so that the software knows what to look for and how to connect the different things. So what we want to do, the time and measurement, it's fine. The species, and you can see here, that's what we were talking about veterinary species. You can see that you've got cats as well in the species. So here, the species is human, so we're going to select human. The organ is peripheral venous blood. The compartment is plasma. And the molecule is midazolam. In our case, it's quite straightforward because we've got only one. So one thing that we are going to do as well, if you see on the right-hand side, the way that the preview of the data, you've got the column, which could be called treatment, but in that case, it's called group. And so we are going to group by treatment. Given that we've got only one group, it's probably not necessary here, but we are going to do it so that you know that if you've got different treatment, you can do that. So we are going to group by group. Okay. Now we are going to click on Add Current Sheet. And you can see that you've got an import preview on the right-hand side of your screen. And what we want to do, because we want to have a name that is not too long, because otherwise you can see that the data set here, the name is very long. So what we're going to keep, we're just going to keep the source, the sheet, and the group. So you can delete the rest in there. Up. And make sure that you got only one dot in between. And you can see that now the name of the data set is Data Smith IV 5 milligram midazolam male. When you're done with that, yeah.
There are two questions regarding the observed data.
Yeah.
What if we have observed data for both genders?
Oh, you can group by gender if you want to differentiate. But
yeah, then you have an extra column,
yes,
right? With gender, and then you group.
Yes.
And there's one more question, if there's a standard template on how the observed data should be organized for PKSIM.
I don't know if we've got a standard template. I'm not sure. Carla, do you know?
I think in the OSP website there is one, but as long as you map the data, even if it's not the same
Standard.
template, it's fine.
Yeah. It's the mapping which is important. I mean, and the good thing is that also you've got the preview, so you can see that if your preview doesn't look good, it means that probably the mapping is not correct. Okay.
Okay, thanks.
Okay, so now we can just click on import. And you can see that on the left-hand side, in the observed data, I've got my observed data there. So you should have the same here. So now we are on the first catch-up point. And I think there was, yes. So just a reminder, the effective molecular weight is used to calculate the permeability. So it's important for you to make sure that you include your allergens, that you mention your allergen, and the data should be in a PKSIM format, but we just discussed it, and with the mapping, even if it's not perfect, but the format, to be honest, is quite standard. Even if you're going from PBPK, then you can just define the column that you need to use, and it's going to be relatively straightforward. Okay. So now we've prepared all our building blocks, so we are very happy with that. And what we are going to do now is that we are going to create a simulation. So we are going to move to the Simulation Explorer, so the Explorer below. And as we did before, we are going to right-click on the simulation and then select Add Simulation. So we are going to call it Smith 1981 IV 5 milligram MIDA. So just good working practice. I mean, this name is for the exercise, but good working practice. Make sure that your simulation name is meaningful. So it's always good to have the route of administration, also the dose, maybe in what you are going to do. If you've got preclinical species and clinical data, then you should write human or dog or whatever to make sure. And here in that case, because it's based on literature data, you see that at the beginning, you've got the name of the publication. So you can put it at the beginning or at the end. The importance is just that it's meaningful to you so that when you come back to your project, you know what is in your simulation and what you were simulating, okay? So first we're going to go through the model structure, but here it's pretty straightforward because we only have one individual, so it's a standard male that we had before. We've got only one compound, midazolam, but then you could choose if you've got more than one. And then we can see that in the model setting, you've got the standard model for small molecules, because if you go in the drop-down menu, you've got model for protein and large molecules. But most of the time for small molecules, you're going to use the standard model for small molecule. So we can click on next. And then here, we're not going to change anything at this point in time, but I mean, there could be parameter alternative. If you've got more than one building block, then you could have alternative here that you want to select, but you can see that they grayed out. So in our case, because we've got only one building block for each building block, then we don't have any alternative. One thing which is important, and that we are going to come back to it later on during the exercise, is that you've got some calculation method. So you've got calculation method for the cellular permeability, and you've got 3 different ones. If you want to have information about it, you can go and have a look in the documentation. But one thing which we are going to deal with today is the partition coefficient. And you can see in PKSIM, in a lot of things where you hover over the item, you can have an explanation about what it is. So it's a method to calculate the intracellular to plasma partition coefficient estimation. And in that case, we've got 5 different methods. So by default, you've got the PKSIM standard method, but if your model is not perfect, then you can try, depending on the characteristic of your compound, to try a different method. But here, for the moment, we are going to leave it as it is. In the processes, so if you remember, we specified the glomerular filtration under assumption. Then the administration, so we can see, and you can see on the graph, you can see again whether your dose is in milligram and not in milligram per kilogram. Otherwise, you're not going to have a very good model. And then the events, we didn't define anything. And observer, we didn't define anything. So now we can click on OK. And now it's creating our simulation. So you can see on the on the left-hand side that in our simulation, we've got the simulation that has been created. So we are going to open it. So to open it is just double click on it. And one thing that I want to do, and for once I remember to do it before, is in the setting. If you can go to the settings, you will see that our observation go only until about 8 hours. So you've got the start time, and you can see that you've got more or less point depending on where you are in your concentration versus time profile. So a good working practice is not to have a graph that goes until 24 hours if your observed data go until 8 hours. So you can choose the end time, either 8, 9, or 10. So I will take 9 just to make sure, because I don't know if the last point is 8 point something. Sorry. Okay, so yeah, so that the prediction will be over the same duration as the observation. And one thing that I haven't done before, but you can do it, so it's do file, save, and then you can do save or save as. It's the same because it's the first time. And I'm going to call it my simple PBPK model. And often what I do when I save, I mean, here I called it this way, but if you save a project, make sure again to save it with a meaningful name and probably the molecule and what your project is about, so that when you open it, you know what is in there.
There's a question regarding partition coefficients.
Yes.
It was noticed that the Lukakova calculations is not in there. Are there plans to add this? And
No.
what is the difference about the PKSIM standard calc method?
Okay. Okay. So you can find really in the documentation, and I've had a look. And so the different partition coefficient method. So the Lukakova method is not implemented. It's something, I don't know if it's proprietary to GastroPlus, but obviously it was developed by Viera, who is working for Simulation Plus. So I don't know if it's proprietary, but there are, as I was mentioning, the 5 different methods. So you can have a look and see, as I was saying, and I don't remember on the top of my head, but some are more suitable for ionizable compound and so on. So the answer is no. I don't think that the Lukachova method is going to be implemented, but we can double check, but I don't think so. And then if you want to have details, again, you can go and see what is more applicable to your compound. But we are going to do some optimization of the method, so we can discuss that also a bit further later on. But if you want the detail, please go and have a look in the documentation. I mean, if Carla, you've got any other information with regard to that?
Yeah, not really. I can send the link to the description of all methods.
Thank you.
The documentation, yeah.
Thank you, Carla. Thank you for your question. That's very interesting. Okay, so now what we are going to do, we are going to run our simulation because that's what we want to see. We want to see how it's behaving. So you can see my mouse. So you get on the top, you can go to the orange circle with the white arrow, run, and then you can click on run. And here what you see is the curves that are going to be simulated. In our case, we just want to have one curve. We want to have the plasma, which is already selected. And if you wanted to have the concentration in other tissue, you could select them there and add them to your simulation. So we click on OK, and you will see that it's very fast. So now we do have some simulation, which is nice. And normally, if you change the setting, so it's not exactly as it is in the example, but if you change the setting, you should have it going to 8 or 9 hours, depending on what you choose. Now, what we're going to do to see whether our model is doing a good job, we are going to include the observed data. And here, it's really straightforward because you just need to go in the building blocks explorer, click on your data, and then just drag and drop. And voila. So it's so easy, it's very nice. So here what we can see is that, the data are going up to 8 hours, but we can see that the model is not really doing a very good job regarding the prediction. The distribution is not well predicted here, and the elimination we can't see very much, but the distribution is definitely not very well predicted. So just a good habit as well is make sure if you click on the tab Observe Data, so next to the time profile analysis, make sure that your simulation output is showing your observed data, because later on when you want to do sensitivity analysis or parameter optimization, again called parameter identification in PKSIM language, then it will help you if it's mapped. Normally it should be mapped. If not, make sure just to include it. Just to show you before we go further, if you want to change the layout of your graph, you can go on the right-hand side. For example, if you say, okay, I want to have my observation that are the same color, you can just click on the drop-down menu on the color and then select the same color or black color or whatever. Okay? So what we are going to do in the next step is that we are going to try and improve our model because it's not really satisfying. And we can also have a look, and that's something that I'm doing as well, on linear scale. And we can see that whether it's on log or linear scale, the model is not really, really good.
There's a question.
Yes.
What is the purpose of the reaction diagram subtag?
Okay. Here we don't have anything. So reaction diagram is something that you will find in both PKSIM and MOBI, and it's where you've got enzyme. So when we will have introduced the enzyme, you will see that there is something on the reaction diagram. But here, because we haven't introduced an enzyme, you don't have anything. But you can have a look later on when we introduce the enzyme in the model. But that's a good question.
Thanks.
So we're on capture point 2. So just as a reminder, but I hope that everyone got it by now, that building blocks are used to create the simulation. And again, if you've got more than one building block for the different components, then you can choose the one that you want to use in the simulation. So now what we are going to do, we are going to do a sensitivity analysis. And what we are going to do, we are going to run the sensitivity analysis, and then we will have a short break again. And then after that, we'll do the parameter optimization. Okay, so here we are in the simulation building block. And we are going to do a right click on the simulation. So you can see that you've got the contextual menu and you've got the start sensitivity analysis. So you click on it. And again, you could have done, if you see my mouse, at the top of the ribbon, you've got something which is called parameter identification and sensitivity. So if you prefer to work with the ribbon, you can work with that. Okay, so here in the example, I'm not following exactly the example, but you can follow the example. That's absolutely fine. In the example, it says add all constant. But if you're adding all constant, it means that it's going to add all the parameters that are in your PBPK model and that you're going to do sensitivity analysis on all of that. For me, and as I was mentioning at the beginning, to update your physiology as a first step is probably not what you want to do. What you want to do is see whether there are things in your compound that you can modify that would make sense. And updating your physiology is not really something that you want to do, at least initially. So what you want to do is see in the molecule what are the parameters that have an impact on the PK. So the way that I'm doing it, and again, if you want to add all the constant at once, feel free to do that. It's really up to you. We are going to arrive to the same conclusion, but for me, from a model building perspective, I prefer to do it that way. So I click on the first characteristic of the molecule, and I click on the last one. And then I click on add. So not add all constant, otherwise you're going to take all the constant, but I click on add, and it's going to add the constant that I've selected. So you see already I've got 26 parameters. And if, for example, I think, okay, something is not relevant and I want to remove it, I can just go on the right-hand side and delete the entry, because here we don't have bromure. So anyway, but, and also I could delete all the things that are not relevant to my molecule, for example, things that are related to large molecule, but it doesn't matter because obviously it's not going to be run. And you will see that the algorithm in PKSIM is very, very fast. So having 25 parameters is not going to be an issue. Another thing that I want to mention is that you can see here that you've got the variation range and the number of steps. So the variation range is the fraction change in your parameter. So for example, if we are talking about fraction and band, let's say the fraction and band is 2%, then if you have got a variation range of 0.1, it means that your fraction and band is going to be changed by 10%, okay? So that means that it would range from 1.8 to 2.2. Personally, I think it's too small. For some measurement, you can think that, okay, the variation range makes sense if it's been measured. For me, I think it's a bit too small. So I prefer to have a variation range which is a bit bigger. So what I take is about 50%. But again, feel free to keep it at 10% if you think that's enough. Then the number of steps is also the number of steps that it's going to take to run the sensitivity analysis. So in that case, it's 2 steps. So if I've got a variation range of 0.5, then the first step would be at 0.25, so 25%, and second step at 50%. Plus or minus 50%, okay? So in my case, I say, yeah, I want to add a few steps. And again, you will see that the algorithm, PKSIM algorithm, is extremely fast. So even if you add a few steps, it's not going to slow you down very much. So for me, what I'm doing, I think, okay, I've got 50%, I will have 5 steps. And then you can decide whether you want to update the number of steps for all the parameter or for selection. I think it will take more time to select. And again, as I was mentioning, because it's so fast, it doesn't matter. So what I'm doing is I update the variation range to 50% for all the parameter and the number of steps for 5 to 5 for all the parameters. Then you can see that here we are in the run and analyze, and we are going, and you can see that we've got the tooltips that tell us that we are going to run the active sensitivity analysis, which is what we want to do. So now you can just click on run.
Good, we have a confirmation question. Just to confirm, 0.5 in the variation range is plus minus 50% from the mean value, and number of steps is how many numbers will be generated within the defined range.
Yes, exactly. I couldn't have explained it better. That's exactly that.
Perfect, thanks.
Okay, and you know, just during the time of the question, we've got the results. So you can click on OK. And before going into the number in the results, I want to go into the sensitivity analysis here on the top. So here you can see that you've got the parameter that is being tested. At the bottom, you've got what we call the sensitivity value. And here you've got the PK parameter that is being considered. Because the sensitivity analysis is assessing what will be the impact of your input parameter, for example, in that case, the lipophilicity, on your PK parameter that you're considering. So usually for me, what I prefer to consider is AUC 0 to T. So in PKSIM, it's called the AUC TN. So it's AUC to the last quantifiable point. I prefer to do that because when you take the AUC to infinity, you also have the impact of the terminal half-life. And if your model is not very good, then it's going to have a double impact. So I always prefer to use AUC TN, but it's really up to you. And so here, in our case, what we can see, if you really want to keep it simple, you will see that initially we had many, many parameters, and here on that graph, we've got only a few. If you put all the parameters, if you moved all the parameters, including the physiology parameter, you will have much more parameters on that graph. But if you did same thing as I did, then you should have a result which is hopefully similar to mine. And so the closer the value to 0, the less impact the parameter has, the input parameter has on the PK parameter. Okay? So here we can see, okay, we've got the partition from plasma to blood cell and so on, but it's not so interesting. But we can see that definitely the lipophilicity is the parameter that has got the biggest impact on the AUC 0 to T. And we've got a value which is called close to -5. And we can see, if you look, if you put your mouse on the point, you will see the exact value that you've got. So it's -4.876. So it's about -5. It means that if you're moving your input parameter, so your lipophilicity, by a certain %, then your AUC will decrease, because it's a negative value, will decrease 5-fold more, okay? So that means that if you're changing your lipophilicity by 10%, then your AUC 0 to T will decrease by 50%, okay? And then we can see that also we've got the fraction unbound, which is at about -0.5, so that the two biggest parameter, impactful parameter, but definitely the lipophilicity is the biggest one. Then if you want to have a look at the numbers, then you can go into the tab results. And here you can see all the different parameters and all the input parameter, which are here on the left-hand side, and then all the PK parameter, which are the output parameter. And you can see the ones that are different from 0.
There's a question.
Yes.
Isn't plus minus 50% from the mean value too big of a range?
It's really up to you. I mean, normally the output that you will get, you can try. If you think it's too big, I mean, again, it depends on the parameter that you're considering. For fraction and bound, especially if you've got the fraction and bound, which is extremely small, then the accuracy is probably not great, and so you could have that. So for me, that's why I'm doing 50%. But I mean, if you prefer to do 10%, but I think thinking that the variation in your in vitro measurement is less than 10% is optimistic, I think. But it's really up to you. Again, you know, I'm not saying you should do that. I'm just saying that's the way that I'm doing it. If you want to keep 10%, if you think 10% is sufficient, I mean, you can try to do 10% and see what you get as a result if you get something very different.
Thank you.
Okay. And we are at capture point 3, and I'm going to show you. So yeah, so that's what I was saying for the sensitivity analysis. My recommendation, at least when you are working on your model development, is to only select the molecular properties, not all the properties. I mean, afterwards, at the end, in some cases, you may want to select all, but at the beginning, I would recommend that. Again, my recommendation. Rename the sensitivity analysis because in our case, we're not going to do it, but it's very easy. You just need to do a right click on your sensitivity analysis and you can change the name. And it was a recommendation from Carla because if you've got a lot of sensitivity analysis, then it helps you find which one is which one without having to open all of them. Again, the number of step and variation range can be changed, doesn't need to be changed, but it can be changed for all of for a selection of the parameter. And the sensitivity value is the ratio of the change in the PK parameter, so in our case, the AUC 0 to T, to the change in the input parameter. And here, again, it's really what I discussed previously, is that the x-axis correspond to the sensitivity value, and here, if we consider the lipophilicity, it's the change of a given parameter relative to the chosen PK parameter. And if you've got a positive value, it means that the change in the input parameter will go in the same direction that the change in your PK parameter, whereas if it's negative, it's going to go into the opposite direction. And another way to see that is also that the sensitivity value is the slope between the percent change in your input parameter, so in our case, the lipophilicity, and the percentage change in the PK parameter. I'm not sure whether this slide is useful or if it's more confusing, but I hope that it helps. Yeah. Okay. So now we're going to take another small break. And then the next step will be for us to do some optimization following what we did on the sensitivity analysis. Okay, there are some questions.
Not yet. No, I don't think so.
Okay. Okay, great. Okay, so it's 14 past 11 in Central European time. Let's meet back at 20 past. So it's a short break, but just to refresh the brain a bit. And I'll see you in a bit more than 5 minutes. Okay. Can you see my screen?
Yes, we can.
Yes.
Thank you. Also, there was a question regarding whether the recording will be available after the session. Yes, so it should be available on YouTube, but we are doing that session monthly, so probably not every session will be available on YouTube, but we will check with our marketing manager, sorry about that. We are going to check with our marketing manager to know when it is, but hopefully it's going to become soon. And please follow ESQlabs on LinkedIn so that you will know when it's released on YouTube. Okay, so let's get back to it. So now what we did, we ran the sensitivity analysis and we saw that lipophilicity is the most the parameter which is the most impactful on the AUC. And again, and it was a question that we had at the beginning, it's not so surprising because we saw that we had a range in the literature. There was a range for the lipophilicity, and it was ranging between 2.9 and 3.9. So here that confirmed that, yes, indeed, maybe the value is not 3.9. And if you started with 2.9 or with another value, then you would have had the same results. Okay, so we are going to do similarly to what we did for the sensitivity. So you can go into the parameter identification and then do parameter identification. But again, I always prefer to do it from the Explorer, so the Simulation Explorer. So I create, I click, right click. Again, I get the contextual menu and then start parameter identification. So I've repeated that already, but I want to repeat it because it's a different language. In PKSIM, parameter identification means parameter optimization. So here, when you click on the parameter identification, we get the data. So we only have one data set, so we know that it's that one. And then we are going to go into the parameter tab. And here, because you want to find the parameter that you want to optimize, we are going to click on lipo. And you don't even need to click on find, it already found it. And you've got lipophilicity. So you click on lipophilicity, and then you click on add. Okay? So you can see that on the right-hand side now, we've got the lipophilicity parameter, that we've got the start value, which is 3.9. And then that we've got the boundaries that have been set up by the software. So the boundary is ranging from -10 to 10. It's extremely large boundary, but it doesn't matter because it means that the software will be able to go into the full space. So it's not a problem. And again, you will see that the algorithm is very fast and that it's not an issue. One thing to remember, if you're running an optimization, so identification, if your value is very close or is on the boundary, it means that you've got a problem with your parameter. We can go to the top and then click on the run button. And you see it's extremely fast. It took less than 1 second, which I was very impressed about yesterday because I'm on a virtual machine and it was extremely fast. So now we can click on OK. And then we can see the results. So you can see in the run property that you've got the number of evaluation that in run to completion, meaning that you don't have a problem with the run and when it was done. And also here you can see the value that you got, the optimal value. You've got the start value and you've got the boundary. And what is very nice, which I find really useful, is that on the right-hand side, you've got a graphical display. So you see that the boundary are the blue lozenge and blue diamond, and then you've got your optimal value, and then your start value. And also one thing which is always good, it's a bit same thing as what I was saying when I was saying that you need to have a look at your molecule before looking at the properties to make yourself an idea about what you're expecting. In our case, if you remember, for the from the literature, the value of the lipophilicity was between 2.9 and 3.9. And we can see that here the optimal value is 3.47, which is well within that range. So it means that the value makes sense. If we had a value at 1.5, for example, we could worry and wonder whether it makes sense. So now what we can do, because we are happy with that, we can do the time profile. And here we can see that, okay, time profile is improved, much improved compared to what we had previously, but it's not perfect. But anyway, for the moment, what we are going to do, we're going to go back to the results. And on the right-hand side, you can see that you've got this little white checkbox, green checkbox, and we're going to transfer to the simulation. Okay. So now we transfer the value to the simulation. And if you look at your simulation explorer, you can see now that that you've got a warning, okay? And if you hover over the warning, you can see that it said the compound setting were changed compared to template compound. So it means that you've got that what you've got in your building block is not synchronized with what you have in your simulation. So now what we want to do, because we think, okay, the optimization is better than what we had initially. So we want to update the value in the building block. So to do that, you right click on midazolam in your simulation explorer. And then you see that you've got three things. And I'm just going over that because it was something that I had difficulty I was a bit confused about initially. So you've got three different possibilities. So show differences is quite clear, but then you've got update from building block. It means that if you've got a value in your building block and you want to update your simulation. Second one is commit to building block. It means that the value that you've got now in your simulation, which was the optimized value, is going to be updated in your building block. And that's what we want to do because we optimize it and we want our building block to be synchronized. So we just click commit to building block.
There are a couple of questions.
Yes.
So in the parameter identification, what is the log in the drop-down box?
The log? Which log?
Yeah, I think if you go, it was already a while ago, so to data.
Yes.
Oh no, parameters.
Yes.
I think this maybe the scaling in here.
No, it's because
I don't know. Can someone confirm?
Yeah, it's because the lipophilicity is always it's on a log scale, so that's why it's log units. But it's just for that parameter because when you've got the log P or log MA, it's a log, so that's why it's a log unit.
Yeah, no, I think it's the scaling, linear
Yes.
or log.
Ah, here.
So that's how the software.
Yes. Sorry, I thought that it was a log unit here. Yeah, so it's how the software is going, the step that it's going to take. If it's linear, it means that it's going, let's say, I'm going to say something for the log, maybe it's going to go every 0.1 or even less because it's 3.47, but every 0.1, whereas it's on the log scale, it could go to 0.001 and then 0.1 and then 0. And then 1, something like that. So you can try to see whether it makes a difference. Normally, it shouldn't make a difference. If you want to investigate a big space, most probably you would want to go on log scale if you don't want to spend too much time. But here, given the speed of the algorithm in PKSIM, I think it's fine to keep it on linear scale. Does it answer the question?
Thanks.
Yeah. Okay, great.
And another question is, can you perform a global sensitivity analysis with intercorrelation for the parameters selected?
Alors, my understanding is that you can't do that in PKSIM, but you can do that in R.
With the OSP suite package, indeed.
Yes, exactly. And thank you for confirming, Carla. So, at the beginning, I was explaining about the OSP suite, and I was saying as well that we are doing some R programming and stuff like that to broaden the use of the OSP suite, and it's one of the use, yes. So the global sensitivity analysis is something you can do with R within the OSP suite. Does it answer your question?
Yes, thank you.
Right.
And then one more confirmation question. So with this parameter identification, in this case, the model takes into account the observed data we inputted to determine the optimal log P, right?
Yes, absolutely. Absolutely. What the model is doing is that it's trying to decrease the difference between your observation and your prediction, and to find the best parameter for that. But sometimes it's not enough with one parameter because you've got some misspecification in your model. So it's not just a case of optimizing a parameter.
Perfect. Thank you. That
You're
was it.
welcome. Thank you. So here again, we can see that the distribution phase is much better than it was before. And I always like to have a look on the linear scale. If we look on the linear scale, it's not too bad, but it's not very good. And we should continue to do that. And now let's say that, the development of the compound, even if it's midazolam and it's known, but in a real life scenario, we know now that the compound is metabolized by CYP3A4, so we are going to integrate a CYP3A4 into the model. Before we do that, I just want, because we are at catch-up point 4, so I just want to reiterate what I was saying before to make sure that we wrap up this thing. The update from building block is from the building block to the simulation, where the commit to building block is from the simulation to the building block. Maybe it was obvious to everyone, but for me, it was something that took me a little while to understand. So to save you time, now you've got that. Again, parameter identification is equivalent to parameter optimization. And here we could have optimized both the log P and the fraction unbound in our case. But as we saw, the impact of the FU was far less than the log P on the PK parameter. So that's why we decided to optimize only one. We could have done, again, the FU if we wanted, because of the fact that we knew also that in the literature it was a range that was suggested from 1.6 to 2.4, so we could have changed that. And I mean, if you're interested, you can also try to do it and see whether it makes some difference. Okay. So now we are going to add the metabolizing enzyme, CYP3A4. So first, we are going to go in our building blocks. So in the building blocks explorer, and you double click on your standard mail, because here we want to add an enzyme. So if you remember at the beginning, initially, we went through the different tab, but we said expression. We are going to come back to that later. So this is the moment where we are coming back to it. So you click on the expression tab. And then in the metabolizing enzyme, you right click, add metabolizing enzyme. Here, we need to click on the plus to create a new expression profile. And it's human. It's CYP3A4. And the phenotype, we can call it standard male. And it is the advantage because you can, if you've got extensive or a poor metabolizer, you can create different expression profile for the same protein. So here we click on OK. And then we've got an expression profile set with our value. So click on OK, sorry. Okay. So we need to double check whether you've included your human expression database, and I hope that you did. So to do that, what you can do, and I checked yesterday and it was good because as I was on the virtual machine, it was not in there. So you click on the tab Utilities, Option, and then Application. So I repeat, Utilities, Options, Application. And here you can see that I've got my database. If you just downloaded your database on somewhere, in your download folder or whatever, and it's not showing there, then it's quite straightforward. You click on the three dots here, and you go to the folder where you downloaded your database, and then it's going to go in there directly. Okay? So obviously I'm not going to do it because I already have it. Okay. So does everyone have their database? Oh, no, I will put it differently. Does anyone, I don't know how to say it in English, does anyone, is someone without the database? Sorry. So if you don't have the database, raise your hand. Okay. Brilliant. Okay. So,
Oh, there is someone.
yeah, I saw that. So if you don't have the database, you need to go into the same place as before. So in the in the OSP to find the database. So let me see if I can copy the link. Yes.
The link was copied by a participant in the chat.
Thank you, Rana. Okay. Yeah. So if you, So Chiara, if you downloaded the database, you need to put it where I said, and then we are going to, once you got it, it means that it's available, and then we're going to input it into the model. But you need to make sure when you go to Utility, Options, and again, Application, that you've got it there for your human. If you've got it there, then we are going to continue to make sure that we've got the right expression and so on. And that's the next step that we are going to do. So I will assume that you've got it there as well, Chiara. Okay. Okay, so what the first thing that we need to do is, okay, so in the expression profile, you can see that now you've got on the left-hand side in your building block, the CYP3A4 human standard male. And you need to make sure that the localization is intracellular. And once you've double-checked that, which should be fine, then you click on Database Query on the right-hand side. When you do that, you can see that you've got two names. You've got the CYP3A4 and CYP3A43. So we are going to select the first one, CYP3A4. And then we click on Next. And then here you've got the distribution depending on the different assay that we have. And again, if you want to know more about the assay, there is a free training that you can follow. It's free for everyone. And it's on protein expression, protein database. So you can follow that so that you will know the difference between the different assay and the accuracy and so on. In our case, we are going to select the RT-PCR. And you can see here that you've got some, so it's reverse transcription polymerase chain reaction that we're going to select. And then you've got, again, in the training, you've got more explanation about the value that are available, the data that are available, and the accuracy, and the one that should be chosen. Most of the time, we are going to take the RT-PCR. So you click on RT-PCR.
Question in between, is there also expression database for other species?
Alors, there is, it's something that is being worked on, and so it's something that you can download, but for the moment it hasn't been fully validated. So you can use it, but you've got to be cautious knowing that it's not fully validated.
Thanks.
But it's been available for a little while, so hopefully it's going to improve. So now we can click on OK. And then we will go to the compound because we need to say that the compound is metabolized by CYP3A4. So we double click. So again, to open a building block, you double click on it. So here we double click and we go to the Admit tab. And if you remember before, we put the renal clearance. And so now we are going to the metabolism, metabolizing enzyme. And we right click and we do add metabolizing enzyme. So here the enzyme is CYP3A4. So if you click on the drop down menu, you will have the CYP3A4 at the top because it's the one that we use first. And the data source, it's called, you don't need to write it all, but if you want, you can write it. Why don't I get it? So it's Patke et al. 2003, RCYP3A4. So RCYP is for recombinant on CYP. Okay, so already we know a bit what we're dealing with. Metabolite, so if you want to model your metabolite as well, you can add it there. And as I was mentioning before, it's also something that you can do if you're working with a prodrug. In our case, we're not going to do that. And then the process type, if you go down in the process type, it's the third before last. So 1, 2, 3. It's the in vitro metabolic rate in the presence of recombinant CYP, or CYP, enzyme Michaelis-Menten. So I'll leave it for just a second. So in vitro metabolic rate in the presence of recombinant CYP, enzyme Michaelis-Menten. So in our case, we've got the Vmax. So the Vmax is the maximal velocity of the enzyme. So it's the maximum rate at which the enzyme can work. And here it's 0.32. And when we enter that value, so you can see here, I've entered the in vitro Vmax. And here you can see that the kcat, which is a parameter which I think is specific to PKSIM, you see, and if you hover over the information, you can see that it's the number of substrate molecule each enzyme site convert to product per unit time. So it's the in vitro Vmax divided by the recombinant enzyme, by the number of recombinant enzyme. And then we've got the Km, which is the concentration at which you've got half the maximum velocity, and it's 0.8. And then I think there are some questions.
Yes, thank you, Natalie. About that, on what basis process type is chosen?
Excuse me?
So you see, how do you choose between in vitro clearance, Michaelis-Menten, and all these options?
Okay. So it depends on what you've got available. So in that case, you see that the data, because it's RCIP, it's coming from recombinant enzyme. So already you would select recombinant enzyme. And because you've got here the Vmax and the Km, you can go with the Michaelis-Menten. If you only had the clearance, then you would probably go with a first order one and not a Michaelis-Menten. So that's how I would do that. And then if you've got liver microsome, then if the value was coming from liver microsome, you would take the in vitro metabolic rate in the presence of the liver microsome. So it depends on where your value is coming from and what value you have, if you've got only a clearance again, or if you've got the Vmax and the Km. And before that, someone was asking also, if you don't have the value, how can you do that? So if you've got an idea, as I was mentioning, based on publication on similar compound, then maybe you can try to do that type of thing here and do some optimization, as we are going to do later on. But again, it's a bit risky if you don't have any information. But I hope that it answered the question regarding how you select which one you want.
I think so.
Okay, great. Well, and there was another question?
Yes.
Yeah.
Yeah, no, sorry. Yes, it's the answer.
Okay, great. Okay, that's good. So now we click on OK. And again, you can see that as before, we've got some exclamation mark, and it's because now we've changed some of our building blocks. And so now, again, the building blocks and the simulation are not synchronized anymore. So what we need to do, we go to the simulation and we do a right click. And now what we want to do is we want to configure to make sure that we are taking the building blocks that have been updated. So we are going to go to configure. And then you can see here, there is enough warning. It says it's not the right one that you should use. You've got the warning. So if you click on the drop-down menu, you can see that there is another one, the standard mail. And the standard mail is the one that we have updated, so where we created the enzyme. And similarly for the compound, you can see that it says this is not the template building block. So we are going to take the other one where we just included the CYP3A4. So here we're not going to do anything. And here, if we go to the processes, if you remember, before we only had the glomerular filtration, but now we've got the glomerular filtration and we've got the enzyme as well. So it's great. So we can click on OK. And now you can see that the exclamation mark in the simulations have disappeared. So it means that you have updated and that your building blocks are in sync with your simulation. If it's not the case, it means that there is a problem, but hopefully it's the same. So now, if you go on the simulation, we opened it, and now you can see that the time profile analysis is the same as what we had initially. and it's not been updated. So we are going to run it. So we're on the simulation, we do a right click and then run. And now, damned, we can see that it's not very good. Okay, we are very far from that. What happened is that we have integrated some data from the enzyme, but they are in vitro value. And it's often that when you've got in vitro value, you will get something which is not optimal for your profile. And also we optimize the log P and so on. And so we will need to do some more optimization. So that's why we are going to do that. And we are going to optimize some of the value that we have. When you have in vitro measurement, you can have also some scaling factor regarding the potency of your in vitro assay versus what you observe in vivo, and that's a scaling factor that you're entering. Here we don't have that, so we are going to optimize the value that we have. Okay, so we are going to go back to our parameter optimization, if you remember. So on the left-hand side in the simulation explorer, we are going to go to the parameter identification one. Now we're going to go to the parameters, and we have the lipophilicity, which is fine. And now we are going to look for the KCAT. So I highlight it to you. So the KCAT is just the Vmax normalized by the number of enzyme. So KCAT. And then you see someone was asking about the reaction. So now the KCAT is in the reaction. Up. You click on KCAT and you add it to the right-hand side. You can see also that now the lipophilicity has come back to the initial value, and that's what it should do. When you do optimization of different parameters in your model, you should do them together, because otherwise you're not sure that you get the best value. So that's good practice that it's coming back to the initial value that we had. And now we've got our two things, so we can see again the boundary are very large, and we can just click on run, and you can see that we are well in the parameter identification, so parameter optimization. And again, it's very fast. So we can go into the time profile. Is it the one which is, I'm going to click again. Yeah, it's the same. Just wanted to make sure. Okay, so the time profile, so we can see that, okay, it's okay, but it's not perfect. And if we look at the results, we can see that the lipophilicity is at 3.33. So sorry, in the run properties, we had no problem. But we can see that the optimal value for the lipophilicity has changed. It was 3.47 before, and it's now 3.33. Well within the 2.9, 3.9 range that we had. And we can see that the KCAT has decreased drastically to 0.78. Here, it's much more difficult to do a sanity check because we don't have the scaling factor for the in vitro to in vivo extrapolation. So again, if we look at the time profile, we can see that it's okay, but it's not really optimal. If we look at the linear scale, which is always good, we can see that, okay, in some cases, I guess that you would stop there. Also, if you've got variability, here we've got just the average curve without any variability. So it's not too bad. It's not perfect, but it's not too bad. But we are going to see whether we can make it better.
Someone got an error.
Ah, okay. What was the error?
Mm.
I'm trying
No.
to. So what is the error?
No output mapping.
So yeah. So I
Defined.
think it's probably when we did the simulation, if you remember, I'm going to try to see. Yes. When you are in the simulation, you've got the observed data. In that case, I don't know why it's not mapped, but normally it should work like that. I edited the parameter. Yes. Yes, so sorry, in the data, can you make sure that you've got your outputs that shows Smith? So in your parameter identification, that your outputs show the observed data as well. So the Smith 1981 midazolam peripheral venous blood. And if it does, rerun it. If it doesn't, make sure that you map it. Does it solve the problem?
Yes. Thank you.
You're welcome. Okay, so yeah. So we were there. So yeah, not too bad, not perfect. So now what we are going to do is we are going to rerun it again, but this time we are going to double check which one of the different partition coefficient calculation method is going to be the best one. Okay, because we are using by default the PKSim, but whether it's the best one really for our compound, we don't know. And again, if you want to know more, have a look in the documentation. I don't know if you shared it, Carla, but otherwise you can have a look on the OSP suite and have a look at it to get all the detail about the different partition coefficient. So now what we are going to do, we are again in the parameter identification one, and we're going to go into the configuration. Okay. So we are not going to change anything. I mean, depending on what you're doing, if you want to change some of the things there, feel free to do that. We are not going to do that. And if you go on the second part of the screen, then you've got the option and you've got different options. If you click on the drop-down menu, you've got multiple optimization, so randomized start values. It means that if you are really looking for complex optimization, sometimes you may want to start on different value so that you are not in a local minima. So, you know, so that you don't have a problem, and you should normally have the same results every time. If you don't have the same result, it means that you are in a local minimum. So it's something that you can do if you've got complex optimization. But what we are going to do ourselves is we are going to check the calculation method variation. So select that one. And then we can do the cellular permeabilities or the partition coefficient. Here we are going to do the partition coefficient. So you select that, and in our cases, we are going to run all of them. Given the question that we had before, I mean, and from what I read, there are different methods depending on whether your compound is ionizable or not. So maybe you wouldn't want to select all of them necessarily. But here in our case, we are going to do that. So you, again, probably something to think about what you want to do. On the other hand, what we want to do is to have the best volume of distribution, and so the best KP method. And yeah, it's quite nice because then you can directly compare all of them, so not one by one. So it's really nice. Okay, so we are going to select all of them. So the 5 of them. And then now if you remember, we've got our 2 parameters, and then we've got our 5 different methods. So it's going to take a tiny bit longer than when you've got only the 2 parameter, but you will see that again, the algorithm is very fast. And so you click on run. So again, make sure you're in parameter identification, run, and then let it do.
In the meantime, we could maybe do some questions.
Yes.
Does the same process apply also to transporters?
Same process. What do you mean?
I think for the parameter identification, first doing a sensitivity analysis, then maybe parameter identification.
I would think yes. I don't know if you've got an idea on that, Cleo or Carla. I would do it similarly.
Yeah, same.
Okay.
Yeah, me too. And if I do a simulation for some other drug without any fitting data, how should I validate?
If you've got, yeah. So if I guess if I understand the question correctly, and please correct me if I'm wrong, is that if you're doing some prediction and you don't have any measured data, that's what I was saying at the very beginning of the training, is that it's something that you can do, but the uncertainty will be very high. If you don't have anything to double check, so whether it's preclinical species or something, your uncertainty will be very high. So it will be just a prediction, but whether it's a true prediction or not will be extremely questionable.
Yeah,
Okay.
thanks. One last question. Can we do all methods together for all KP values and fitting data with all methods at the same time?
Yes, that's what we did. That's what we are doing now. So I'm not sure I understand the question.
Oh, it's already okay. Yeah.
Okay, yeah, because it's actually what we did.
Yeah.
We know that the parameter that we need to optimize are the lipophilicity and the KCAT, and then we want to see what is the KP method that allow us to get the best results. And again, as I was saying before, if you've got a good reason not to select the 5 method, then and to eliminate one of them, for example, then do that. But I mean, otherwise, again, you saw it did all that in less than 25 seconds. So there's no reason not to try it, to try to see which one would give you. So really the KP method is working on the partition coefficient, and so it's working on the volume of distribution. Okay.
Perfect, thanks.
You're welcome. So I click on OK here, and then we can go to the results. So here you can see, all of them run to completion, so great. And then we can see one thing which is important is the total error. So the lower the total error, the better. So in that case, we can see that the worst one is the Poulain tail, with a quite high total error compared to the other. And then we can see that the second one, which was the one that we were using, the PKSIM standard, is also quite high. Then it's followed by the Bereskovsky method, and then the Rogers and Roland, and then the Smith method. If you want to see, and I think that's very nice to have a look at that, if you want to see the value of the optimized parameter, you just need to click on the plus here. And then you can see again for the Rogers and Roland. So the Rogers and Roland and Smith are very close to one another. So we can see that the lipophilicity is 3.10 and that the KCAT is 3.02. And then if we look at the Smith, then the lipophilicity is a bit higher and the KCAT is a bit lower. So in all cases, we don't have problem. We are not close to the boundary. But after that, either you can say, okay, whatever, I'll take the the lowest total error, or you can say, okay, first I want to have a look at my profile because it's not just a question of number. So here you can see that we've got the 4 different curve. So the way that I'm doing it, and then after that you can do it the way that you want, is if you hover over it, I will. So you can see here, normally I should be able to see the different method. So if you don't see it directly, which method is which one, just click again on the time profile a second time. It's a little bug. And then now, you see, if I click on the curve, I can see everything. I can see the concentration, and I can see what is more important to me. I can see the run number, and I can see which one it is. So we saw that the puller and tail was the worst one. It's number 3. So I'm going to remove it in the legend. So I remove the visible from the legend, and I can see, okay, this one was not good. We see also when we look at the graph that this one, the PK sim standard, is number 2, is not too good either. So I'm going to remove it because I just want to choose which one would be the best between the one that I'm left. And this one is the Smith, so okay. And this one, we can see that there is a difference in the distribution. There is something which is not so good. And it's the Bereskovsky method, which is the run number 1. So I'm going to remove it. And then you can see that from these 2 curves that actually the results are pretty close to one another. In the example, you will see that the selection is done on Smith. To be honest, for me, I prefer that one because it describes better the elimination. So I'm going to keep the Roger, the Roland and Roger. Again, you don't have to do that, and again, when you do modeling, it's also a question of experience and of feeling. It's not just a question of statistics. So feel free to continue with the Smith method. It doesn't matter. It's not going to do a big difference. But for me, because it describes the elimination better, I prefer to keep the Roger and Roland. Okay? So now we go back to the results. And so depending on which method you want to keep, whether you want to keep the Smith method or the Roger and Roland, you go to the transfer to simulation square. Okay, so if you choose the Smith, obviously you take the Smith check thingy, transfer to simulation. If you want to do the Roger and Roland, then you click on the transfer to simulation. Okay. So, yeah, so there are some questions?
Yes, there's one. I think you haven't answered it, right? For new chemical entities, how to refer literature values of lipophilicity and KCAT. I mean, parameters will not be available in the literature. In that case, how to move forward?
For the lipophilicity, again, lipophilicity, and I've worked, as I was saying, in clinical pharmacology for a long time. Normally, lipophilicity is a value that you would get quite early in the development. If you don't have it, I don't know if there are some QSAR tools that you can use. Carla, do you know?
I know there are free open source ones, but not directly in PKSim, no.
Okay, so then that's the way that you would do is look for a free QSAR tool and then try to use the value which is predicted by your QSAR tool. But again, for these parameters, which are quite important, and it's experiments that are not really complicated to run in vitro. And really, as I was mentioning at the beginning, there are some parameters where it would be important to have in vitro measurement. If you don't, you can go with a QSAR, but you know that you are increasing your uncertainty.
There was another one. You have selected some literature reported methods. For new chemical entities, this option will not be available. How to fit the curve in that case?
Can you repeat again?
Yeah, so you have selected and unselected some literature reported methods. For new chemical, this option will not be available. How to fit the curve in that case?
I'm sorry, I don't understand the question.
Yeah, me neither. What is the option that you're referring to?
Yeah, I don't know what I did with selected and unselected. So anyway, I know that we are, in the middle, but because there is still a bit of things left, just keep your screen as it is now. We are going to take another break because there's still about an hour to go, and I know that it can be tiring, and so we need a bit of fresh air. So leave it like that because it's important what we are going to do next. And then the person who had the question, can you try to reformulate it in another way? Because I don't understand what your question is and what you're talking about selected and unselecting. So, and then we can reconvene at, for me, it's 12 past 12 Central European time. So we can reconvene in 8 minutes. So at 20 past 12 Central European time. So in 8 minutes. Okay. So it's 20 past. So I'm going to continue. I hope that everyone is back because it seems that there are some raised hands. Okay.
Yeah, it's me for the question.
Okay.
So now that it's specified, it's for the curve fitting when we unselected some methods. So I'm trying to ask how to select the appropriate methods for curve fitting, for new chemical entities.
Okay.
For
Okay.
discovery molecule.
Okay. Okay. So if you don't have any observation, obviously it's going to be very difficult. If you've got some observation, like I was showing before, then you've got, when you try the different method, you will have the total error, which is calculated. So it can give you an idea again. So it's really some statistics that are calculated based on the difference between the prediction and the observation. But then, as I was saying, either you can say, okay, I just trust statistic and I will take the lower total error, or as I did, is try to also have a look on the graph to see which curves would be the best to bring forward for your model. For me, in my opinion, but again, that's where modeling becomes a art and is not just statistics. I think that the one where the terminal half-life is better characterized is probably better. But in our case, we will still have that uncertainty because, again, we can see that the lipophilicity and the K-cat will be a bit different. So in discovery case, if you don't have observed data, it's going to be complicated. If you've got observed data, then you should probably do it the same way. I hope that it answers your question.
And maybe just to mention also that if we don't have observations, we can still, depending on the parameters that we have and the compound, each formula has the different specifications, and we can
Yes.
choose
Yes.
based on that, even without observations.
Absolutely, absolutely. Yes, indeed. And that's a very good point. I said that before, but it's always good to repeat that some will be more applicable to ionizable compounds and unionized compounds, sorry. So if you look at the 5 different methods, you will be able maybe to exclude some of the method based on the property of your compound. But again, yeah, with some uncertainty, it's going to be difficult to be completely certain if you don't have observed data. But I know that in early discovery, you don't have much, or when you work in chemical as well. Okay, any other question, or can we move forward? Okay, so I guess we can move forward. So everyone should have the same thing as I have on my screen. So it's a warning that when we were transferring the parameter, it says only the values of the identified parameter will be transferred. Please set the calculation method manually. So what it means, in fact, is simple once you know what it means, is that it means that the log P value and the K-cat value are going to be transferred, have been transferred, but then the method, so the KP method calculation has not been changed. So you will need to do it yourself. So that's what we are going to do in the next steps. So click on OK. And again, as we saw before, we can see that we've got some warning as we had previously. And what we want to do is we want to commit to the building blocks. So it means that we want to have, because we think that the optimized value are the best value, we want to update the building block. So it's what we were saying previously, okay? So we want to commit to building block, meaning that we want the value that we've got in our simulation to be inputted in the building block. So we are going to choose commit to building block. Okay? And then after that, what we want to do, because now we've dealt with the value, but again, you can see here, you can see here when I hover over the the simulation, you can see that the partition coefficient method is still PKSIM standard. And it's not what we want because we saw that the best one were Roger and Roland or Schmidt. So depending on which one you choose, so now we are going to do a right click and then configure. And then now we are going into the, can never remember if it's in the compound. Yes, it is in the compound tab. So in the compound tab, if you remember, we had the partition coefficient. So here we are just going to go in the drop-down menu, and depending on what you want to do, for me, as I was saying, I want to use the Roger and Roland, so I'm going to select that one. But for you, feel free to select the Schmidt if it feels better for you. Okay. And now, alors, we need to make sure that the simulation is open. And now you can see again that the time profile analysis is still showing an exclamation mark because it hasn't been updated. So now we are going to run it. And now we can see that the model is excellent. And if you did the Schmidt, it's also very good. I know because I did both. So then we are happy. Now the next step, and it's the last step in the exercise, we are going to create a population simulation. So what we've done so far is we worked, and it's what you do when you do model building, is that we work on an average individual. Now what we're going to do is we want to create a population so that we've got an idea about the variability that is going to be observed in our population. So there is two ways, as we did before, to do it is you go to the building block here on the population and you do a right click, or in the modeling tab on the top, you can click on population. So as I was saying, you can do both ways, it's fine. So I'm going to do it that way, and I do add population, and we are going to call it European population. And then we are, and it's based on that. We can see, I'm diverging a bit from what is in the example. Feel free to do it again with the example, but it's also because I've worked in clinical pharmacology. And so here we can see that the age is 0 to 100 years. In a real study, you would never have an age like that. So, I mean, you could assume that it's a phase 4, but it wouldn't be healthy. So I prefer to have a more reasonable age for clinical study. Again, it's not going to change, it's just practice, so it doesn't really matter. So for me, I'm going to take 18 years old to, let's say, 60, which is already quite old for a clinical study. And then the only thing that I'm going to include is a BMI. So it's the body mass index. And usually, at least in study in Europe, the body mass index will be between 18, let's say, and 30. If you are in different population, your body mass index could be different. For example, in the American population, usually it goes to higher than 30. But anyway, it's really just because for me it makes more sense and I want it to be close. So when you are doing a population, if you're doing it for real for you to predict what is going to happen in your next study, make sure that you've got your parameter that are as close as possible to your protocol criteria for your study. For example, I'm working with a client on an American study. So the population that we took was the American population, and then the body weight and the age was in agreement with the inclusion and exclusion criteria from the protocol. So we are going to do next. And then we can see that, okay, it's the same as what we had before. That's fine. And for the anatomy, we're not going to do anything, so we're going to do next. And we can have a look, if you want, at the for the distribution. We can have a look. As you saw, I defined the BMI between 18 and 30, and you can see here that I've got all my population, which is within this BMI, and you can check the different distribution. What is nice as well is that you can check either stacked, so one on top of each other, or you can have them side by side to see how the population was created. Then we are going to click on OK. And now what we want to do is we want to create a simulation. So what we are going to do is we are going to take the simulation that we created for one individual, and we are just going to clone it because it's going to be very similar. So you right click on the simulation that we call Smith 1981 IV 5 mg/m, and you're going to go on clone. So it means that it's just going to copy it exactly as it was. But in that case, we are going to call it same name and add just population at the end to be clear that it's a population simulation and not an individual simulation. And here we need to change, the only thing that we need to change is the individual or population, because before we were saying we just want to have a standard male, but here we want to have the European population that we just created before. So we can click on next, and it's what we selected before. So for you, if you selected Schmidt, you will see the Schmidt in the partition coefficient. Then we click on next, and then we click on OK. Okay. So now we are going to go and run the simulation, and you need to make sure that you are on the population simulation and not on the MIDA. So make sure that you are on the population, and then you click on run. So you can see that it's creating all the simulation. If you look on the bottom, so it takes a bit more time. And then here you've got the create time profile analysis, which opens. Here we are fine because it's a peripheral venous blood that we want to represent. And on the right hand side, we've got the midazolam peripheral venous blood plasma concentration. And we can rename the output to have something a bit better. So we are going to call it plasma midazolam. So you just need to click on the cell and then write plasma midazolam. Okay. Then the scaling is on log, so you can decide whether you want to have it on log or linear, because you will not be able to change that afterwards. And you can see that we've got underneath, we've got a lot of statistics that can be used to display. The arithmetic mean is selected by default, but it's not what we recommend to use for concentration, because concentration are log normally distributed. So either you should take the geometric mean or the median. So you unselect the arithmetic mean, and then I will select the median. And then I will select the range from 5% to 95% percentile, which means that we will have a 90% prediction interval. So next you click on next, and then again on next, until you can click on OK. And then you click again on OK. And now, so we've got our nice population simulation. So you can just do the same as what we did before, just drag and drop your observed data onto your graph. It's going to be to look a bit different to what you've got in the example, because in the example, it's not the same scale, it's not the same time scale, but here you can see that the observed concentration are well within the population simulation. So that was the end of the example. I think I may have missed a couple of catch-up points. Yeah, that's that. So we're not on a break. Before I go to the conclusion, and then I've got one more slide to show you, are there any more questions?
Yes, there are some general questions.
Yes.
One is, does biphasic PK curve can be fitted using PKSim?
Yeah, the purpose is not to do fitting, is really to do mechanistics. So that's a bit the difference between compartmental and PBPK. So the disposition in PKSim, the disposition, you're not going to fit it. You are going to try to mechanistically explain it.
Okay, and then if we only have observed data from small and large animals, can we still use PKSim to extrapolate to humans?
Yes, absolutely. And that's something that we do. So depending on the data that you have available, you will have more or less certainty on your prediction. But if you do have more, let's say you've got one or two rodent species and then dog or monkey data, then you can extrapolate to human. Yes, absolutely.
And then it's more like a request. Can you please go back, catch up point 6?
Oh, yes. Yes.
Thanks.
Yes, and as I was saying, you know, when I was selecting the different curve or unselecting to be able to see, I had to click the time profile twice. Sometimes it works directly and sometimes it doesn't work directly. So you will not be able to see which line corresponds to which method. And you can find a way around, but it's a bit of a pain. So the easier way, and it was Carla actually who showed me, is that you just click again on the time profile and then you will be able to have that. Have all the different methods that are shown directly on your graph. And then to rerun the simulation, it's what we say. So you transfer the parameters, then you commit to the building block to make sure that the building blocks are synchronized with the value that you've got in your simulation. And then you configure the simulation so that you change the partition coefficient method to Schmidt or to Roland and Roger, depending on the method that you choose yourself.
And then other question, what the option allow aging mean?
So it's when you are working with pediatric that you can have some aging, but if you're working with adults, you're not going to use that option.
And then a complementary question, if I'm considering genetic polymorphisms, can this be changed in the expression option when we define the population?
You mean genetic polymorphism for the enzyme, I guess, or for transporter? In that case,
Yes.
yeah. So in that case, you would need to change it in the when you configure the enzyme. If you remember when we configured the enzyme, we put LC, but you can put more than one expression for a single enzyme, depending if you've got extensive metabolizer or poor metabolizer. Yes.
Yeah, and in the population we can make it vary as well.
Mm.
Thank you.
Okay. Yes. So please give us your feedback So I will just leave that for a couple of minutes, a few seconds. If you can scan the QR code and tell us what you got from this workshop. Also, tell us things that we should do differently. If you would like us to include more things, again, we're not going to include Mobi, but if there are different things that you would like us or to spend more time or less time, that would be really great. I don't know where it moved, but so yeah. So, and here you can see Carla's address and my address. So if you've got questions, again, or if your company is interested in some workshop or whatever, don't hesitate to contact me. Yeah. And so to conclude with that, thank you for sticking with us. It was great. And thank you very much for being so engaged and participating in that workshop. That was great. It's a long workshop. That's why I'm including breaks, because I think it's important. And otherwise your brain can get frozen by the end. But it's really great that you ask so many questions and so on. And as I was saying initially at the beginning, really before I started using PKSIM, I didn't think that it could be free and good. But I hope that with that workshop, we were able to show you that, yes, it can be free and good as well. And the fact that it's a community is also something that helps, because everyone participates, or not everyone, but many people participate, and we can make it move forward. So hopefully by now you were able to build your first PBPK model following IV administration in the software, and you understood some of the key feature, and I think with the key physicochemical properties and so on, and of the compound that you would need, or how you can circumvent them if you don't have them, how you can use sensitivity analysis and optimization through the parameter identification again, which is the same as parameter optimization. And so you saw the step-by-step. Again, some of the things that we did here, not included the enzyme directly, is not something that you would do in real life, but I wanted to go step by step because otherwise it can be a bit overwhelming. And then you saw how easy it is to compare the result to observed data after running individual and population simulation. And also within PKSIM, it's very easy to compare different simulations that you've done as well. So it's very easy to do that. And so we hope that you are now ready to start investigating PKSIM further, and that you are eager to do that. And one thing that I want to mention as well is that we have some upcoming workshop. So every second Thursday of the month, having said that, sometime it will be the third if there is a conflict, but normally every second Thursday of the month, there will be this workshop that will be rerun. So if you've got some of your colleagues that could be interested, it will be announced on LinkedIn. One time it's on Central European time, so 9 to 1 Central European time, and the alternative months, it will be on American time, let's say, so it will be from 3 p.m. Central European time to 7 p.m. Central European time, so that people in Canada or in the US can connect as well. So in March, it will be from 3 to 7 p.m. Central European time for our colleagues in America to be able to connect. Then there will be some upcoming workshops. I was mentioning that we are doing pre-conference workshop. There will be one at the Quantitative System Pharmacology Conference, which is taking place in Leiden, and it's on the 7th of April. And it will be the theme will be building scalable PBPK QSP models. So it is working with Mobi. Then at the International PBPK Conference on Tuesday, the 21st of April, there will be 4 of the workshops. So one will be basic, where we'll cover the same thing, but also oral. There will be drug-drug interaction, special population, and PBBM, so that you will be able to pick and choose if you want to go to just one, if you've got some knowledge. If you don't have knowledge, or some colleagues want to go, then you can go to the basic, and then DDI or basic and PBBM. And so you can pick and choose what you want to do depending on your interest and on your level already in PKC. And then, as I mentioned before, there will be the Mobi Summer Week. It's running from June 29 in the afternoon from July 3rd in the morning, so finishing at lunchtime to allow people to travel in the morning on the Monday and in the afternoon on the Friday. And it will be fully dedicated to Mobi with 5 of our very experienced instructors. The advertisement is already available on LinkedIn, so feel free to register. And again, feel free to contact us if you've got any question with regard to any of these things. And and this will be also conducted in Basel in Switzerland. We chose that location because we thought it was quite central for everyone to be able to reach it. And with that, I would like to say also, don't hesitate to follow us on LinkedIn. I mean, you may have seen when you register for this workshop that the places goes very quickly. So by following us on LinkedIn, you're more likely to be able to get a spot in the workshop. And finally, again, thank you so much for listening. Thank you for being such a great crowd. And yes, there are still time for questions. We still have a bit of time for questions. So,
And there are
please,
still questions.
Sorry?
And there are still questions. So
yes, I saw raised hand. So, but again, yeah, if you haven't asked a question or something, if you can give us your feedback on the workshop, that would be fantastic. So I'm ready for more questions.
Yeah. So first one is about the summer Mobi summer school. Is it suitable for those with minimal ODE experience?
Oh yes, absolutely. There will be completely. I mean, I'm the training lead at ESQlabs, and there will be no requirement to be proficient with differential equation at all. The prerequisite for Mobi is nothing, so there is no prerequisite for Mobi. The prerequisite is that you've got basic knowledge in PKSIM, because PKSIM is not going to be covered, and Brady is going to help you to have some knowledge in PKSIM. So following this workshop is a good start, and then you can do the free training that we've got online. If you're academic, you can do all the training on PKSIM, and if not, maybe to buy 1 or 2 of the training just to make sure that you're comfortable with PKSIM. But no prerequisite on Mobi any knowledge on Mobi or on differential equation. Good question.
Good, thanks, Nathalie. Then, can we do PKPD modeling in PKSIM? Similar to GastroPlus, can we do dissolution data modeling in PKSIM, like Z-factor, fitting, etc.?
Okay, yes, there is a part that you can do in PKSIM. I'm going to take the dissolution first, so the PBBM part. So some of it is doable in PKSIM. Some will require R as well. So it can be done in PKSIM or in PKSIM together with R. And then with regard to PBPK PD modeling, yes, you can do it, but it will be, and please, Carla, correct me if I'm wrong, because you're more knowledgeable about that. It will be more likely in Mobi that you're going to do the PD.
Indeed, I fully agree. Then, for chemicals having animal data and no human data, what approach can be used for simulating kinetic profile for animal to humans?
Okay, so it's what we were saying, you know, that what you should do. Alors, the best, if you have, is to start with your IV data in animal. Then you can parameterize your disposition, and then you move to your oral data still in animal, and then you do in vitro, in vivo extrapolation, depending on the data that you've got available within the software to go from animal to human. So what you would want to do, if possible, sometimes it's difficult, but if you've got more than one preclinical species, you would want to have a model which is similar within your preclinical species. And I'm saying sometimes it's that feasible. If you've got extremely big interspecies variability, it might be difficult to achieve that, but that's what you should do. And if you can manage to have a model which is the same across the different preclinical species, then you will increase the confidence that you have in your first-in-human prediction.
Thank you, Natalie. And still one, so about the biphasic, still about the biphasic PK curve.
Yes.
Do we need to add compartment to fit this curve?
No, it's really, and I'm sorry if I was not clear, but really the way that we are doing that, when you've got biphasic, it's linked to distribution, so it's linked to the property of the molecule. And the idea of building a PBPK model is using the physical-chemical properties of your drug to describe what is happening and to describe mechanistically, as I was mentioning at the beginning. So it's really understanding what in your property is going to trigger the pharmacokinetic behavior that you observe. So when you add compartment in what I was calling classical compartmental analysis, you are really doing empirical. You are adding compartment just to fit your data, but you're not mechanistic. So I know that for people who are working in PBBM, so in formulation development, sometimes they don't really put so much importance on the disposition, and then they're happy with the compartmental model for the disposition. But in PKSIM, it's not what we do, unless I'm mistaken. Carla, do you agree with me?
Yeah, I fully agree. We can
Okay.
fit it as long as we understand why there's this behavior and that we
Yeah.
implement it.
Yeah, but we are not adding compartment.
No.
Because that's really, again, it's mechanistic versus empirical.
Thank you, Natalie. I don't see any other questions.
Okay. Okay, so I will just give you 7 more seconds in case there are any other questions. So it seems that we are at the end of the question. So thank you very much, everyone. Thank you for being so active and proactive in the workshop. It was great crowd. Thank you. And so hopefully the recording or a similar recording will be available on YouTube soon. And I'm going to contact our marketing manager to see when it's going to be available. If you haven't done so, please give us your feedback. And then I wish you a good rest of the day.
Thank you. Bye, everyone.
Thanks a lot. Bye, everyone.